ಇದಕ್ಕೆ ಬಂದರೆ ಸಾಕು, ಅದು ಅಲ್ಲಿಂದ ತಗೊಳ್ತದೆ. ಅಲ್ಲ ಬರ್ತದೆ ಅಂತ ಇದರಲ್ಲಿ ಮಾತಾಡಿ ಕರೆಕ್ಟ್ ಬರ್ತದೆ.
ಹೋಲ್ ಹೋಲ್ ಹೋಲ್
ಏನಿಲ್ಲ, ಜಸ್ಟ್ ನಿಮ್ಮ ಡೇಟ್ ಆಫ್ ಬರ್ತ್ ಹಾಕಿ.
ಹೋಲ್ ಹೋಲ್ ಚೆಕ್ ಹೋಲ್ ಹೋಲ್ ಹೋಲ್
ಕಂಟಿನ್ಯೂ ಮಾಡುವಂಥದ್ದನ್ನು ಮಾಡಬೇಕು ಅನ್ನೋದು ನಮ್ಮ ಉದ್ದೇಶ ಆಗಿರ್ತದೆ. ಈ ಆನ್ಲೈನ್ ತರಗತಿಗಳ ಉದ್ಘಾಟನಾ ಸಮಾರಂಭದಲ್ಲಿ ನಾವೆಲ್ಲ ಭಾಗವಹಿಸ್ತಾ ಇದ್ದೇವೆ. ಈ ಕಾರ್ಯಕ್ರಮದ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸ್ತಾ ಇರುವಂತಹವರು ನಟೋಜ ಫೌಂಡೇಶನ್ ಟ್ರಸ್ಟ್ ಇದರ ಅಧ್ಯಕ್ಷರು ಹಾಗೂ ಅಂಬಿಕಾ ಸಮೂಹ ಶಿಕ್ಷಣ ಸಂಸ್ಥೆಗಳ ಅಧ್ಯಕ್ಷರಾದಂತಹ ಶ್ರೀಯುತ ಸುಬ್ರಹ್ಮಣ್ಯ ನಟೋಜ ಸರ್ ಇವರನ್ನ ಎಲ್ಲರ ಪರವಾಗಿ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಪ್ರೀತಿಪೂರ್ವಕವಾಗಿ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೇನೆ. ಹಾಗೆಯೇ ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಉದ್ಘಾಟಕರಾಗಿ ಆಗಮಿಸಿದಂಥವರು ಡಾಕ್ಟರ್ ಮಾಧವ್ ಭಟ್ ಸರ್ ಅವರು, ಅಂಬಿಕಾ ಸಮೂಹ ಶಿಕ್ಷಣ ಸಂಸ್ಥೆಯ ಆಡಳಿತ ಮಂಡಳಿಯ ನಿರ್ದೇಶಕರು, ಪುತ್ತೂರಿನ ಸಾವಿರಾರು ವಿದ್ಯಾರ್ಥಿಗಳ ಭವಿಷ್ಯವನ್ನ ರೂಪಿಸಿದಂಥವರು. ಇವರನ್ನ ಈ ಕಾರ್ಯಕ್ರಮದ ಉದ್ಘಾಟಕರಾಗಿ ಆಗಮಿಸಬೇಕು ಅಂತ ಕೇಳಿಕೊಂಡಾಗ ಅತ್ಯಂತ ಪ್ರೀತಿಯಿಂದ ಒಪ್ಪಿಕೊಂಡಿದ್ದಾರೆ. ಅವರನ್ನ ಎಲ್ಲರ ಪರವಾಗಿ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಪ್ರೀತಿಯಿಂದ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೇನೆ. ಹಾಗೆ ವೇದಿಕೆಯಲ್ಲಿ ಅಂಬಿಕಾ ನೀಟ್ ಅಕಾಡೆಮಿ ಇದರ ಪ್ರಾಂಶುಪಾಲರಾದಂತಹ, ನಮ್ಮೆಲ್ಲ ಕೋಚಿಂಗ್ ತರಗತಿಗಳ ಕೋಆರ್ಡಿನೇಟರ್ ಆದಂತಹ ಕಿಶೋರ್ ಸರ್ ಅವರು ವೇದಿಕೆಯಲ್ಲಿ ಉಪಸ್ಥಿತರಿದ್ದಾರೆ. ಅವರನ್ನು ಕೂಡ ಅತ್ಯಂತ ಪ್ರೀತಿಯಿಂದ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೇನೆ. ನಮ್ಮೆಲ್ಲ ಸಂಸ್ಥೆಗಳ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರನ್ನು ಕೂಡ ಅತ್ಯಂತ ಪ್ರೀತಿಯಿಂದ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೇನೆ. ಮೊದಲನೇದಾಗಿ ಈ ಕಾರ್ಯಕ್ರಮದ ಉದ್ಘಾಟನೆಯನ್ನ ಮಾಡಬೇಕು ಅಂತ ವೇದಿಕೆಯಲ್ಲಿರುವ ಅಧ್ಯಕ್ಷರಲ್ಲಿ ಹಾಗೆ ಮುಖ್ಯ ಅತಿಥಿಗಳಲ್ಲಿ ವಿನಂತಿಯನ್ನು ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಮುಂದೆ ನಮ್ಮನ್ನೆಲ್ಲರನ್ನ ಉದ್ದೇಶಿಸಿ ಕಾರ್ಯಕ್ರಮದ ಉದ್ಘಾಟಕರಾದಂತಹ ಡಾಕ್ಟರ್ ಎಚ್ ಮಾಧವ್ ಭಟ್ ಇವರು ಮಾತನಾಡಬೇಕು ಅಂತ ಕೇಳಿಕೊಳ್ತಾ ಇದ್ದೇನೆ.
Hello. Hello.
ಪ್ರೀತಿಯ ಬಂಧುಗಳೇ, ವೆರಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಟು ಎವ್ರಿ ಒನ್ ಆಫ್ ಯು. My salutations to the President of the function, the President of Nataraja Foundation, my friends and principals of Ambika institutions. No need to say that we are slightly caught up in the technical glitches. We apologize. But then, of course, if there is one rule, there are 10 ways of escaping from it. If there is some problem, there are 100 ways of overcoming it, surmounting it. And that's what we are trying to do now. Learning, in fact, has to be continuous. Learning has to be seamless. Learning has to be natural. It's a philosophy that all of us believe in. Sad as it is, there has been some problem. Weather has not been very, very favorable, as a result of which the administration has had to take some decision which may not be in favor of the students who are very keen to learn, use all their 24 hours for learning. Ambika Institution, in fact, has been very sensitive to the needs and aspirations of the students, as a result of which whenever there has been some block, obstruction to learning, they have devised ways of overcoming that and then still reaching out. We still remember what happened during Corona. There was a time when the whole world came to a still. But our president, in fact, saying never say die, in fact thought of, conceived the whole program and then started, and many others actually took the lead as well. This time we woke up slightly late with the hope and prayer that every next morning there is going to be a regular class. But well, it's getting extended, as a result of which we thought we can't wait anymore. As a result of which the administrators took a quick decision. In all these kinds of contingencies, we need to reach out to the students. Their learning has to be promoted, teachers have to be available, and the students' time has got to be very fruitfully utilized. Online class is not anything new to this world. Virtual classes are not new to this world. The best of the lectures are available there, in fact online. They are recorded, and students obviously know. Now we are not restricted to the classroom now, nor are we restricted to one teacher. As a result of which, well, the whole world in fact is an open book for us. We can access, we can at any odd time also think in terms of learning, continuing to learn. I am very happy that Ambika institutions did not wait for the rain to abate, nor in fact the declaration that now the classes can be on. It may be slightly tricky and also funny for some of us that exactly when holidays are declared, the sun is going to be shining bright. But you and I, in fact, do not control this weather, nor in fact the movement of the sun, nor even in fact the movements of the clouds. Come what may, we are going to be ready. Be prepared is our slogan, as a result of which I actually compliment and congratulate the teachers, the institution, the administration to have thought of it. If not today, tomorrow at least we are prepared. In fact, we could have started this had we known that these 4 or 5 days are going to be off days. We would have perhaps started last Thursday itself. But then of course we had to wait, we had to be cautious. We have got to be law abiding. We can't flout the law because district administration knows when and what to do, so much so that we have been very sensitive to these kinds of issues. Well, laws, some of those laws are not to be flouted. We need to in fact follow that. I'm very happy in one sense that our own students, Ambika students, are known to be always alert, always willing to learn. Although a microscopic minority could have actually celebrated when they heard the declaration of holidays. Many of you actually wrung your hands and then said, well, we are missing the classes. You can't miss anything. If you have a will, then there is a way, is what the teacher said, what the administration said, what the students also perhaps are saying. Kindly note that all these kinds of innovations came only when they were thwarted. Look at any one of the work which is going to be moving there, crawling there on the ground. Put your foot to obstruct it, it is going to be skirting the way. That is what we are doing. Regular, online, real classes cannot take place, but should it necessarily obstruct our learning? It need not. Only thing is, we are distanced by quite a few kilometers and miles as well, which means you need to be willing customers. Please note that in this world, anybody is going to be getting for asking. Kindly ask for those classes, and there are always going to be givers. The teachers are always willing. Well, there is a big gap between the real class experience and the online classes. You can even, of course, munch the peanuts and then keep your mobile on, but then, of course, you are deceiving yourself. You can deceive the rest of the world, you can never deceive yourself. I'm very sure all of you are earnest in this very task of learning. Let learning and teaching prosper. And this online class, although there have been some hurdles, some unexpected kinds of, Murphy's law once again operates. Not once, time and again can operate, because we are trying out many things, and many experiments mean many failures, possible failures. But then, as Alva Edison said, 100 times you try to make a bulb, 99 times you fail, but 99 times you are going to be learning how not to make it, and 100th time you are going to be succeeding as well. In the same way as that, I'm very sure that we are going to be succeeding in all of our exercise. Wish you the best of luck. Wish the college the best of luck as well. As I said sometime earlier, let learning flourish. Thank you so much.
ಮುಂದೆ ಈ ಕಾರ್ಯಕ್ರಮ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿಕೊಂಡಿರುವಂತಹ ನಮ್ಮ ಸಂಸ್ಥೆಯ ಅಧ್ಯಕ್ಷರಾದಂತಹ ಶ್ರೀಯುತ ಸುಬ್ರಹ್ಮಣ್ಯ ನಟೋಜ ಸರ್ ಇವರು ಎಲ್ಲರನ್ನು ಉದ್ದೇಶಿಸಿ ಮಾತನಾಡಬೇಕು ಅಂತ ವಿನಂತಿಸ್ತಾ ಇದ್ದಾರೆ.
ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಬಂಧುಗಳೇ ಹಾಗೂ ಪೋಷಕರೇ, ಇನ್ನೊಂದು ಕೊರೋನಾದ ಅವತಾರ ಪ್ರಾರಂಭ ಆಗಿದೆ ನಮ್ಮ ದಕ್ಷಿಣ ಕನ್ನಡಕ್ಕೆ. ಡಾಕ್ಟರ್ ಮಾಧಭಟ್ ಅವರ ಕೈಯಲ್ಲಿ ಶಿಕ್ಷಣ ತಜ್ಞರಾದಂಥವರು ಅನೇಕ ಸಾವಿರ ವರ್ಷಗಳಿಗೆ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ, ಸಾವಿರಾರು ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ 10 ವರ್ಷ ಪಾಠ ಮಾಡಿಬಿಟ್ಟು ತನ್ನ ಭವಿಷ್ಯವನ್ನು ನಿರ್ಮಾಣ ಮಾಡಿದಂಥವರ ಕೈಯಿಂದ ಇವತ್ತು ಉದ್ಘಾಟನೆ ಆಗಿದೆ. ಈಗಾಗಲೇ ಹೇಳಿದಾಗಲೇ ಕೊರೋನಾ 2ನೇ ಅಧ್ಯಾಯ ಪ್ರಾರಂಭ ಆಯಿತು ಅಂತ. ಭೌಗೋಳಿಕವಾಗಿ ಉಡುಪಿ ಮತ್ತು ದಕ್ಷಿಣ ಕನ್ನಡ ಎರಡೂ ಒಂದೇ ರೀತಿ ಇದೆ. ಆದರೆ ಮಳೆರಾಯನ ಅವಾಂತರಗಳು ದಕ್ಷಿಣ ಕನ್ನಡಕ್ಕೆ ಮಾತ್ರ ಜಾಸ್ತಿ ಇದೆ. ಭಾಳ ಆಶ್ಚರ್ಯ ಸಂಗತಿ ಏನಂತಾರೆ, ಉಡುಪಿಯಲ್ಲಿ ರಜಾ ಕೊಟ್ಟಂತಹ ಮಾಹಿತಿಯ ಪ್ರಕಾರವಾಗಿ ಉಡುಪಿಯಲ್ಲಿ ಅಂತ ಮಳೆ ಬರಲಿಲ್ಲ. ದಕ್ಷಿಣ ಕನ್ನಡದಲ್ಲಿ ಇವತ್ತು 6ನೇ ದಿವಸ ಮಳೆಯಿಂದ ವಿದ್ಯಾರ್ಥಿಗಳು ನೊಂದಿದ ರಜೆಯನ್ನು ಘೋಷಣೆ ಮಾಡಿದೆ. ಹಾಗಾಗಿ ಭಾಳ ಆಶ್ಚರ್ಯಕರ ಸಂಗತಿ ಏನು ಅಂತಂದರೆ, ವಿದ್ಯಾರ್ಥಿಗಳು ಇದನ್ನು ಸವಾಲಾಗಿ ಸ್ವೀಕಾರ ಮಾಡುವಂಥ ಅವಶ್ಯಕತೆ ಇದೆ ಅಂತ. ಈ ನಿಟ್ಟಿನಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿಗಳನ್ನು ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ನಾವು ಕೈ ಬಿಡುವಂಥ ಪ್ರಶ್ನೆ ಇಲ್ಲ. ನಿರಂತರವಾಗಿ ನಿಮ್ಮೊಟ್ಟಿಗೆ ನಾವಿದ್ದೇವೆ. ಒಂದೊಂದು ಸಲ ರಜೆ ಕೊಟ್ಟಾಗ ನಾವು ಅಂಥ ಕಾರಣದಿಂದ ನಾವು ರೋಧಿಸ್ತಿದ್ದೇವೆ, ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಅನ್ಯಾಯ ಆಗ್ತಾ ಇದೆಯಲ್ಲ ಅಂತ. ಇವತ್ತು ಅಖಿಲ ಭಾರತ ಮಟ್ಟದಲ್ಲಿ ನೀಟ್ನ ಒಂದು ಅವಾಂತರಗಳು ನಡೀತಾ ಇರುವಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಮಾಹಿತಿಗಳ ಪ್ರಕಾರ ಸರಿಯಾದ ತಪ್ಪ ಗೊತ್ತಿಲ್ಲ, ಒಂದು 20 ವಿದ್ಯಾರ್ಥಿಗಳು ಆತ್ಮಹತ್ಯೆ ಮಾಡಿದರು, ಅದು ಇದು ಅಂತ ತಿಳ್ಕೊಂಡು ಮಾಧ್ಯಮದಲ್ಲಿ ಬರ್ತಾ ಇದೆ. ಆದರೆ ದಕ್ಷಿಣ ಕನ್ನಡದಲ್ಲಿ ಇನ್ನು ಮುಂದಕ್ಕೆ ಇಂಥದ್ದು ಆಗಬಾರ್ದಲ್ಲ ಅಂತ. ಹಾಗಾಗಿ ಕನಿಷ್ಠ ಪಕ್ಷ ನಮ್ಮ ಅಂಬಿಕದ ವಿದ್ಯಾರ್ಥಿಗಳು ದೇ ಮಸ್ಟ್ ಬಿ ಇನ್ ದಿಸ್ ಸೇಫ್ ಝೋನ್. ಈ ನಿಟ್ಟಿನಲ್ಲಿ ನಾವು ನಿರಂತರವಾಗಿ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ತಾಂತ್ರಿಕವಾಗಿ ಬಹುಶಃ ಒಂದು ಅರ್ಧ ಗಂಟೆ ಲೇಟ್ ಆಯಿತು, ಸಹಜ. ಎಲ್ಲದರಲ್ಲಿ ಒಂದು ಪ್ರಾರಂಭದ ಹಂತದಲ್ಲಿ ಅನೇಕ ಸಲ ಇಂಥದ್ದು ಆಗುತ್ತೂ ಸಹಜ. ಹಾಗೆ ವಿದ್ಯಾರ್ಥಿಗಳು ದಯವಿಟ್ಟು ನಿಮ್ಮೊಂದಿಗೆ ನಾವಿದ್ದೇವೆ ಅಂತ ಹೇಳುವಂಥ ಘೋಷಣೆಯನ್ನು ನಾವು ನಮ್ಮ ಆಡಳಿತ ಮಂಡಳಿಯ ವತಿಯಿಂದ ಮತ್ತು ನಮ್ಮ ಪ್ರಿನ್ಸಿಪಾಲರು, ಇಡೀ ಶಿಕ್ಷಕರ ವತಿಯಿಂದ ನಾವು ನಿಮ್ಮೊಂದಿಗೆ ಇದ್ದೇವೆ ಅಂತ ಹೇಳುವಂಥ ಒಂದು ವಿಶ್ವಾಸನ ನಾವು ಕೊಡ್ತಾ ಇದ್ದೇವೆ. ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ವಿದ್ಯಾರ್ಥಿಗಳು ನಿರ್ಗತಿಕರಿಗೆ ಆಗಬಾರ್ದು. ಬಹುಶಃ ಮಳೆ ಈಗ ಸರಿಯಾದ ಮಳೆ ಇನ್ನೂ ಪ್ರಾರಂಭ ಆಗಲಿಲ್ಲ. ಬಹುಶಃ ಇದು ಮಳೆ ಸರಿಯಾದ ಪ್ರಾರಂಭ ಆದ ನಂತರ ಇನ್ನೆಷ್ಟು ರಜೆಗಳು ಬರ್ತದೆ ಗೊತ್ತಿಲ್ಲ. ಹವಾಮಾನ ಇಲಾಖೆಗಳು ಯಾವ ರೀತಿಯ ವರದಿಗಳು ಕೊಡ್ತಾರೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಬಹುಶಃ ಅಕ್ಟೋಬರ್ ನವೆಂಬರ್ ತನಕ ಮಳೆಗಳು ಬರುವಂಥ ಸಂದರ್ಭದಲ್ಲಿ ನವೆಂಬರ್ ತನಕ ಸಹ ಈ ಮಳೆರಾಯನ ಉಪದ ದಕ್ಷಿಣ ಕನ್ನಡಕ್ಕೆ ಮಾತ್ರ ಇರ್ಬೋದು ಅಂತ ನನಗೆ ಅನಿಸ್ತಾ ಇದೆ. ನವೆಂಬರ್ ತನಕ ಮುಂದುವರಿಯುವುದು ಅಂತ ಅನಿಸ್ತಾ ಇದೆ. ಹಾಗಾಗಿ ಇದನ್ನು ಸವಾಲಾಗಿ ಸ್ವೀಕಾರ ಮಾಡಬೇಕು. ಮುಂದಂತಹ ಎಲ್ಲ ಸಂಭಾವ್ಯಗಳನ್ನು ನಿರೀಕ್ಷೆ ಮಾಡಿಕೊಂಡು ನಿಮ್ಮೊಂದಿಗೆ ನಾವಿದ್ದೇವೆ ಅಂತ ಹೇಳುವಂಥ ಮತ್ತೆ ನಾವು ನಿಮ್ಮನ್ನು ಬೆನ್ನು ಇದ್ದೇವೆ. ದಯವಿಟ್ಟು ಮಕ್ಕಳೇ, ಮನೆಯಲ್ಲಿದ್ದೀರಾ ನೀವು, ದಯವಿಟ್ಟು ಮನೆಯ ತಕ್ಷಣ ಮನಸ್ಸಿನ ಆಲಸ್ಯತನ ಬರ್ತಾ ಇದೆ, ಸಹಜ ಸ್ವಭಾವ. ಆದರೆ ಅದರಿಂದ ಎಚ್ಚೆತ್ತುಕೊಂಡು ಇನ್ನು ಮುಂದಿನ ಭವಿಷ್ಯವನ್ನು ನಿರ್ಮಾಣ ಮಾಡುವಂಥವರು, ನಿರ್ಣಾಯಕರಾದಂಥವರು ನೀವೇ ಮಕ್ಕಳೇ. ಈ ನಿಟ್ಟಿನಲ್ಲಿ ಒಳ್ಳೊಳ್ಳೆಯ ಉಪನ್ಯಾಸಕರಿಂದ ಯಾವಾಗ ರಜೆ ಬರ್ತದೆ ಆಗ ಖಂಡಿತವಾಗಿ ನಾವು ಆನ್ಲೈನ್ ಕ್ಲಾಸನ್ನು ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ದಯವಿಟ್ಟು ಈ ದಿವಸಗಳ ಸಂದರ್ಭದಲ್ಲಿ ಇವತ್ತು ಕೇವಲ ದ್ವಿತೀಯ PUCಗೆ ಮಾತ್ರ ನಾವು ಆನ್ಲೈನ್ ಕ್ಲಾಸನ್ನು ಕೊಡ್ತಾ ಇದ್ದೇವೆ. ಬಹುಶಃ ಮುಂದಿನ ರಜೆಗಳಲ್ಲಿ ಅದನ್ನು ಫಸ್ಟ್ PUCಗೂ ಅದನ್ನು ಅನುಸರಿಸುವಂಥ ಕೆಲಸವನ್ನು ನಾವು ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಫಸ್ಟ್ PUCಗೆ ಅದನ್ನು ಮುಂದುವರಿಸುವಂಥ ಕೆಲಸವನ್ನು ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಹಾಗಾಗಿ ಮತ್ತೆ ವಿದ್ಯಾರ್ಥಿಗಳೇ ಧೈರ್ಯದಿಂದಿರಿ. ನಿಮ್ಮ ಭವಿಷ್ಯವನ್ನು ನೀವು ರೂಪಣೆ ಮಾಡಿ. ಗೊತ್ತಿದೆ, ಅನೇಕ ಸಲ ಆನ್ಲೈನಲ್ಲಿ ಅದರದ್ದೇ ಆದಂತಹ ಚೌಕಟ್ಟುಗಳಿದೆ, ಅದರದ್ದೇ ಆದಂತಹ ನ್ಯೂನತೆಗಳಿದೆ. ಆದರೆ ಬೇರೆ ವಿಧಿ ಇಲ್ಲ ನಮಗೆ. ಕನಿಷ್ಠ ಪಕ್ಷ ಅಂಬಿಕೆ ವಿದ್ಯಾಲಯ ಇವತ್ತು ದಕ್ಷಿಣ ಕನ್ನಡದಲ್ಲಿ ಮೊದಲ ಹೆಜ್ಜೆಯನ್ನು ನಾವು ಇಡ್ತಾ ಇದ್ದೇವೆ. ಯಾವ ಸಮಸ್ಯೆಗಳು ಇದನ್ನು ಹೆಜ್ಜೆ ಇಟ್ಟಿಲ್ಲ. ಆವತ್ತು ಕೊರೋನಾ ಸಂದರ್ಭದಲ್ಲಿ ಸಮೇತ ಫಸ್ಟ್ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಮಾಡಿದಂತಹ ಹೆಮ್ಮೆ, ಹೆಗ್ಗಳಿಕೆ ಅದು ಅಂಬಿಕಾ ವಿದ್ಯಾಲಯದ್ದು. ಅವಾಗ ಲಾಕ್ಡೌನ್ ಆಗಿತ್ತು, ಕಾರ್ಡ್ ಸಿಗ್ತಾರಿಲ್ಲ, ಕೇಬಲ್ ಸಿಗ್ತಾರಿಲ್ಲ, ಲ್ಯಾಪ್ಟಾಪ್ ಸಿಗ್ತಾರಿಲ್ಲ, ವಾಯ್ಸ್ ಯಾವುದು ಸಿಗ್ತಿರಲಿಲ್ಲ. ಆ ಸಂದರ್ಭದಲ್ಲಿ ಮೊಬೈಲೈಸ್ ಮಾಡಿಕೊಂಡು ಮೊದಲ ಬಾರಿಗೆ ಅಂಬಿಕಾದಲ್ಲಿ ಆನ್ಲೈನ್ ಕ್ಲಾಸನ್ನು ತರಗತಿ ಮಾಡಿದ್ದೆವು. ಈ ಸಲ ಸಹ ಹಾಗೇನೆ. ಈ ಸಲ ಬಹುಶಃ ದಕ್ಷಿಣ ಕನ್ನಡದಲ್ಲಿ ಎಷ್ಟು ಕಾಲೇಜುಗಳಲ್ಲಿ ಆನ್ಲೈನ್ ತರಗತಿ ಇದೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ, ಬಟ್ ನಮಗೆ ಹೆಮ್ಮೆ ಆಗ್ತದೆ. ನಿಮ್ಮನ್ನು ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಕೈ ಬಿಡುವಂಥ ಪ್ರಶ್ನೆ ಇಲ್ಲ. ಹಾಗಾಗಿ ಡಾಕ್ಟರ್ ಮಾಧವ್ ಭಟ್ ಅವರ ಕೈಯಿಂದ ಇವತ್ತು ಒಳ್ಳೆ ರೀತಿಯಲ್ಲಿ ಯಾರು ಉದ್ಘಾಟನೆ ಮಾಡಬೇಕು ಅವರು ಅದನ್ನು ಉದ್ಘಾಟನೆ ಮಾಡಿದರೆ ನಿಮ್ಮ ಅಭಿವೃದ್ಧಿ ಮತ್ತು ನಿಮ್ಮ ಭವಿಷ್ಯ ಒಳ್ಳೆ ಉಜ್ವಲ ಆಗಲಿ ಅಂತ ನಾವು ವಿಶ್ವಾಸವನ್ನು ವ್ಯಕ್ತಪಡಿಸ್ತಾ, ನಿಮಗೆ ನಮ್ಮ ಆಶಯವನ್ನು ವ್ಯಕ್ತಪಡಿಸ್ತಾ, ದಯವಿಟ್ಟು ಮಕ್ಕಳೇ ಸವಾಲಾಗಿ ಸ್ವೀಕಾರ ಮಾಡುವ. ಜೈ ಹಿಂದ್.
ಈಗಾಗಲೇ ಶ್ರೀಯುತ ನಟೋಜ್ ಸರ್ ಹೇಳಿದ ಹಾಗೆ ಇವತ್ತಿನ ದಿನ ಕೇವಲ ದ್ವಿತೀಯ PUC ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಮಾತ್ರ ತರಗತಿಗಳು ನಡೀತವೆ. ಮ್ಯಾಥಮೆಟಿಕ್ಸ್, ಕೆಮಿಸ್ಟ್ರಿ ಹಾಗೂ ಬಯಾಲಜಿ ತರಗತಿಗಳು ಸಂಜೆ ತನಕ ನಡೀಲಿಕ್ಕಿದೆ. ಇನ್ನು ಮುಂದೆ ಮಳೆಯ ರಜೆ ಘೋಷಣೆ ಆದರೆ ಸೋಮವಾರದಿಂದ ಫಸ್ಟ್ PUC ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಕೂಡ ಆನ್ಲೈನ್ ತರಗತಿಗಳು, ಹಾಗೆ ಕಾಮರ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಕೂಡ ಆನ್ಲೈನ್ ತರಗತಿಗಳು ನಡೀಲಿಕ್ಕೆ ಇದೆ. ಸೊ ಈ ಉದ್ಘಾಟನಾ ಕಾರ್ಯಕ್ರಮದ ಕೊನೆಯ ಹಂತಕ್ಕೆ ನಾವು ಬಂದಿದ್ದೇವೆ. ಈ ಕಾರ್ಯಕ್ರಮದ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿಕೊಂಡಿರುವಂತಹ ನಮ್ಮ ನಟೋಜ ಫೌಂಡೇಶನ್ ಟ್ರಸ್ಟ್ ಇದರ ಅಧ್ಯಕ್ಷರಾದಂತಹ ಶ್ರೀಯುತ ಸುಬ್ರಹ್ಮಣ್ಯ ನಟೋಜ ಸರ್ ಇವರಿಗೆ ಎಲ್ಲರ ಪರವಾಗಿ ಪ್ರೀತಿಪೂರ್ವಕವಾದ ಧನ್ಯವಾದವನ್ನು ಸಮರ್ಪಿಸ್ತಾ ಇದ್ದೇವೆ. ಹಾಗೆ ಈ ಕಾರ್ಯಕ್ರಮದ ಉದ್ಘಾಟನೆಯನ್ನ ಮಾಡಿದಂತಹ ಶ್ರೀಯುತ ಮಾಧವ್ ಭಟ್ ಸರ್ ಇವರಿಗೆ ಕೂಡ ಎಲ್ಲರ ಪರವಾಗಿ ಪ್ರೀತಿಪೂರ್ವಕವಾದ ಧನ್ಯವಾದವನ್ನು ಸಮರ್ಪಿಸ್ತಾ ಇದ್ದೇವೆ. ಅಂಬಿಕಾ ನೀಟ್ ಅಕಾಡೆಮಿ ಇದರ ಪ್ರಾಂಶುಪಾಲರಾದಂತಹ ಶ್ರೀಯುತ ಕಿಶೋರ್ ಭಟ್ ಸರ್ ಇವರಿಗೆ ಕೂಡ ಎಲ್ಲರ ಪರವಾಗಿ ಧನ್ಯವಾದವನ್ನು ಸಮರ್ಪಿಸ್ತಾ ಇದ್ದೇವೆ. ಹಾಗೆ ಈ ಆನ್ಲೈನ್ ತರಗತಿಗಳು ನಡಿಬೇಕು ಅಂತಂದ್ರೆ ನಮ್ಮ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಟಿವ್ ಆಫೀಸರ್, ಸ್ಟೂಡೆಂಟ್ ವೆಲ್ಫೇರ್ ಆಫೀಸರ್ ಆದಂತಹ ಹರ್ಷಿತ್ ಅವರು, ಹಾಗೆ ನಮ್ಮೆಲ್ಲ ನಾನ್ ಟೀಚಿಂಗ್ ಸ್ಟಾಫ್ಗಳ ಸಹಕಾರ ಅತ್ಯಂತ ಪ್ರಮುಖವಾದದ್ದು. ಅವರಿಗೆಲ್ಲರಿಗೂ ಕೂಡ ಧನ್ಯವಾದವನ್ನು ಸಮರ್ಪಿಸ್ತಾ, ವಿದ್ಯಾರ್ಥಿಗಳು ಈ ಅವಕಾಶವನ್ನ ಸದುಪಯೋಗ ಪಡಿಸಿಕೊಳ್ಳಿ ಅಂತ ಹೇಳ್ತಾ, ಇನ್ನೇನು ಕೆಲವೇ ಕ್ಷಣಗಳಲ್ಲಿ ತರಗತಿಗಳು ಆರಂಭವಾಗಲಿಕ್ಕಿದೆ. ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳು ಇದರ ಸದುಪಯೋಗವನ್ನು ಪಡೆದುಕೊಳ್ಳಿ ಅಂತ ಹೇಳ್ತಾ ಉದ್ಘಾಟನಾ ಸಮಾರಂಭವನ್ನ ಮುಗಿಸ್ತಾ ಇದ್ದೇವೆ. ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ.
morning, dear students. Beacons are at the tip of your fingers. So I'm here from Mathematics Department, Shiny, to handle the lengthiest chapter of PU Mathematics, integration. And we have split it to 2 to 3 CET sessions. Out of the first one will be handled today. We are with the first 2 exercise of integrations. Let me say the importance of this chapter in the competitive examination. In the CET exam, there will be 4 to 5 questions from the same chapter. The past year, I mean this year, in the month of April, the CET, there was 6 questions from integration chapter. So 6 mark in CET paper will count a lot. So let us prepare it. And regarding the JEE examination, the same chapter counts 2 to 3 questions in the JEE paper. So it is such an important topic. Don't be demotivated by seeing the questions. Once if you understand this, it is very good. You can answer it. Be confident. Let us start the chapter. So all of you are ready, right? Okay. So let us recall the formula what we have studied in this chapter. Number of formula we have come across. Let us list out. So first of all, we have come across integral of x to the power of n dx. And you all know, you might, if you were in the classroom, definitely you will shout with the answer. It is x to the power of n plus 1 divided by n plus 1 plus c. And based on the same, there are some more formulae. It is better you remember because different n values will give different formula. So here, let us consider 1 divided by x square dx, and it is clear that n is equal to minus 2 because x power 2, it is in the denominator, and the answer is minus 1 by x plus c. And the other one, that is square root of x dx, n assumes the value half, so the answer will be 2 divided by 3 x to the power of 3 by 2 plus c. That is n attain the value half. And if it is 1 divided by square root of x dx, and you know from direct differentiation itself you come across this 2 root x plus c. And one more, integral of 1 by x dx. So here the answer will be log of modulus of x plus c. And you students, you are very good in a formula. You have studied it in the regular classes. We have revised it a number of times. And the next one is related to the exponential functions. Let us go for integral of a power x dx. So here it will be a to the power of x divided by log a to the base e plus c. So we are just recollecting the formula which we have studied. You all know it. So integral of e to the power of x dx, which is e power x plus c. And the next one, we have the list of trigonometric formula. So here integral of sine x dx, immediately after the differentiation classes, when we start with this, there is lot of confusion in this. Derivative of sine x, integral of sine x. Now all of you are very sure about this. Integral of sine x dx will be minus cos x plus c. And next is integral of cos x dx, which gives the answer, that is sine x plus c. Then directly from the derivative formula, integral of secant square x dx, which gives tan x plus c. We have practiced in our differentiation classes, that is derivative of tan x, it is secant square x dx. So integral of secant square x dx, it is equal to tan x plus c. Similarly, we have the next one, that is cosecant square x dx. Its integration is minus cot x plus c. Also along with that, we have integral of secant x into tan x dx. And you know the answer, it will be secant x plus c. One more, integral of cosecant x into cot x dx, which gives the answer minus cosecant x plus c. So these are the formulae which we get directly from differentiation formulae. So let us go for the other four trigonometric functions, that is integral of tan x dx. By substitution method, we have derived the formula in the classes. Now you know it will be log of mod of secant x plus c. Let us go for integral of cot x dx. Even that you know, it will be log of mod of sin x plus c. And the other thing I forgot to inform you is that every material is uploaded in our app. You can access it from that. Okay, let us come back to this integration of secant x dx, which gives the answer log of mod of secant x plus tan x plus c, as well as integral of cosecant x dx. Even this, by the method of substitution, we have derived it, log of mod of cosecant x minus cot x plus c. So these are the formulae related to trigonometry. Along with this, we have studied some more formula related to inverse trigonometry. We have studied derivative of sine inverse of x is 1 divided by root of 1 minus x square. So integral of 1 divided by root 1 minus x square dx, it is equal to either sine inverse of x plus c, or else we can also write it minus cos inverse of x plus c. Similarly, from derivative of cot inverse and tan inverse, we can bring out the next one, that is 1 by 1 plus x square dx. So here it will be either tan inverse of x plus c, or else we can write it as minus cot inverse of x plus c. And the last one, that is integration of 1 divided by x into root of x square minus 1 dx. That we get it from secant inverse of x as well as cosecant inverse of x, which gives the answer secant inverse of x plus c, or else one more, that is minus cosecant inverse of x plus c. So these are the list of formula we come across. I haven't touched the exercises from 7.4. Just starting basic topics, just formula based as well as substitution based. Actually, there are three methods of integration, different types of integration. One of that is substitution method. The other one is by the method of partial fraction as well as by the method of by parts. So let us go to all the methods, that is by parts as well as partial fraction. In the coming sessions, let us discuss substitution method as well as directly formula method. So by now you might have recalled every formula under integration chapter. So let us start with the questions for discussion. So these questions are very simple, easy to handle it. So we'll have to think, just think a while. See here, we are with the first question. Integration of tan x divided by secant x plus tan x. Is there a formula related to the same? Or now the denominator is sum of two terms. We are unable to break it or split it. What shall we do? See, it's very simple. It's easy. You just go for rationalizing the denominator. So when you rationalize it, here we have integration of tan x as it is in the numerator. We need to multiply secant x minus tan x. Whereas when you multiply secant x minus tan x to the denominator, it is of the form a plus b into a minus b, which simplifies to a square minus b square. And you are all very sure about the denominator with trigonometric identity. It is 1. Secant square x minus tan square x, it is equal to 1. So we know we have to just open the bracket, denominator reduced to 1. So we are with secant x into tan x as the first term after opening the bracket. And the next term is minus tan square x. And do we have formula for tan square x under integration? No, we have to use the trigonometric identity and we have to bring into one of those. So this secant x tan x will be there as it is. We will have to write this secant tan square x as secant square x minus 1 dx. So let us integrate it. Each term is ready for integration. So the first term from the ready-made formula, we know integral of secant x tan x, just recalled, it will be secant x. Then integration of, here minus sign will be there, integral of secant square x. It is from the list of formula tan x. See, this after opening the bracket, it will be plus. So it will be integral of 1 dx, which will be x plus c. So let us opt, the right option will be option B. Just a minute. Sorry. Yeah, let us go to the second question. Yeah, here is the next one. Yeah, here we are with the next one, that is integral of 1 divided by 3 minus root of 3 minus 4x dx. See, we have in the list of formula integral of 1 by root x dx. Just recall, what is the answer for this? Yeah, its answer is 2 times root x dx. Does it resemble the same? Yes. So there is a coefficient for x. What is the coefficient? It is minus 4. So all that you have to do is just substitute into this formula. When you substitute into the very same formula, you get it as 2 times root of 3 minus 4x. But the extra work we have here is x has the coefficient minus 4. Just divide the entire answer by minus 4. So that is all the change. After cancellation, you get minus half root of 3 minus 4x. That is option D. So hope you understood the first two questions discussed. Yes. Let us come to the next one. So that is integration of 2 minus x square divided by 1 plus x square. Actually, it looks like a topic from method of partial fraction, but we can handle it very easily. It's so simple, just addition and subtraction will help us. So it turns to the direct substitution formula. So here, there is 1 plus x square in the denominator. Let us do one thing. Slightly we will change. We will add 1, simultaneously subtract 1. Minute adjustment in the numerator. And the other 2 terms in the numerator is as it is. So the denominator will write it same. So this is the function. And now we are going to split it. Basic simplification. When you split it, here it will be 3 divided by 1 plus x square is the first term for integration. For the next 2 terms, let us keep the negative term outside, sign. When you keep the negative sign outside, it is nothing but 1 plus x square divided by 1 plus x square dx. So is it not cancelled? on cancellation, here it simplifies to 1. So we know the formula list. From the formula list, we are here with the answer. The first term on integrating 1 by 1 plus x square, it is nothing but tan inverse of x. So we have, that is 3 tan inverse of x minus, after cancellation it is just 1 dx. Integral of 1, it will be x plus the constant c. Let us go for the answer. It will be 3 tan inverse of x minus x plus the constant c. That's all. So hope you understood what changes. See, actually when you see this problem, you may feel like it is an improper fraction. It is so, but we can add and subtract and reduce it to the simple fact. Hope you understood. If you are getting the session, you are understanding, I believe. Okay. Next, it looks a bit complicated, only its appearance is so. See, let us go for this function, the first part of it. We have always come across the exponential function as well as logarithmic function. They are mutually inverses to each other. E power log x, it is nothing but x. So just keep that in mind and observe this question. Is it not a simple fact, the first term? It just looks like that. So here we can make a simplification. E power, let us use the property of log. This minus x will be here, 2 raised to minus x. Into the next term is 2 power x dx. So when you simplify this, this has changed to 2 to the power of minus x, because exponential as well as log are inverses to each other. They get cancelled. So 2 to the power of minus x into 2 to the power of x dx. Now the base is same. Your simple high school fact. When the base is same, add the numerators. You get it as integral of 2 to the power of 0, which will be 1. So integral of 1 dx simplifies to x plus c. So the answer here will be option B. Do you know such a simple question was one of the questions of your seniors 2026 KCET question. And again came out trigonometry. Let us go back to our first PUC trigonometry classes. You might have enjoyed the classes there. So let us recall, what is tan 3x? We are able to write tan 3x in terms of tan 2x plus x and write it using addition formula. When you use the addition formula and when you simplify this, you reach with the answer that tan x into tan 2x into tan 3x can be easily written as tan 3x minus tan 2x minus tan x. So, see, it was actually product of 3 functions. We have studied integration by parts. There, it should not be product of 3, even if it is 3, we will have to bring into product of 2 functions. Moreover, it should be varieties of functions like inverse trigonometry, exponential, algebraic, etc. But here it is trigonometry itself. We don't have any transformation formula to change into sum or difference of 2. So this is the method we have to do. Hint, it is only this much. We will have to write tan 3x in the form of tan of either 2x plus x and use addition formula, simplify it. When you simplify the product of these 3, it just simplifies to tan 3x minus tan 2x minus tan x dx. Now we are with the answer. What is integral of tan x? Integral of tan x is log of secant x. So here there is tan 3x, integration of tan 3x, which will be log of mod of secant 3x. But x have a coefficient, so you just need to divide by 3. So similarly, the next term, it gives, let us search the answer. Why to write and waste time? We have to be a bit quick, is it not? See, just observe this option. Log of secant 3x divided by 3, and as x has a coefficient 2, here it will be log of secant 2x divided by 2, and the third term is directly tan x, that will be log of secant x. So the answer will be option B. Yeah. Once again, a question related to transformation formula as well as trigonometry. See, we can't divide it sine 5x by 2 divided by sine x by 2. What is the method? Have you studied any quotient rule under integration? No. So, what we can do is simple, very simple it is, bit of simplification, that is all. There is sine 5x by 2 and here it is sine x by 2. You just multiply and divide it by cos x by 2. Just wait, my dear students. There is some technical issue. We'll come to it. Okay. Yeah, we are back again. So here it should be cos x. So the function we'll need to multiply by is cos x by 2 as well as divide by cos x by 2. So we know the formula, multiple angle formula. So in order to adjust it, we are dividing as well as multiplying by 2. So when you see the denominator, is it not multiple angle formula of sine? 2 sine theta cos theta. So we know the simplified answer will be sine 2 theta, 2x by 2, which will be x. And the numerator, we have come across a formula under first year PUC transformation, that is 2 sine x cos y, which is equal to sine of x plus y plus sine of x minus y. So let us substitute that here. When using that formula in the numerator, it will be sine function. The two angles 5x by 2 added to x by 2. So it will be 6x by 2 simplifies to 3x. And the next term plus sine of, you have the difference of the two angles 5x by 2 minus x by 2, which simplifies to 4x by 2, which is 2x. So much dx. So now you know the formula for sine 3x as well as sine 2x. Let us substitute it. On substitution, here the first term will be sine 3x, that will be 3 sine x minus 4 sine cube x. And the second term is sine 2x, which is 2 sine x cos x. And it is actually divided by sine x dx. So let us go for the first term. Sin x cancels with the sin x. Term for integration is 3. And the next term, 1 sin x gets cancelled. It will be 4 sin square x. When we are with integration of sin square x, you all know the formula to be replaced is 1 minus cos 2x divided by 2. So after replacing that, see, let me do that simplification of this much portion separately. So that sin square x, on simplifying, you will have to rewrite with this. And here, after substituting it, 4 into 1 minus cos 2x divided by 2. And the last term, 2 sin x cos x divided by sin x will be 2 cos x. And now the terms for integration. The first term, on integrating, you get it as 3 and 3x, so that will be 3x. And after cancellation, we have minus 2. Minus 2, on integrating, you get it as minus 2x. After opening the bracket, the next term for integration will be plus 2 times cos 2x. Integral of cos 2x will be sin 2x divided by 2. And finally, one more term, that is 2 cos 2x. 2 cos x, its integration will be 2 sin x. So all the terms are integrated, and finally we are adding the constant c. 3x minus 2x, here it will be x. And the next term will be sin 2x plus 2 sin x plus c. And that is in one of the options. That is here x, and the other term will be sin 2x plus 2 sin x plus c. That is in option C. It is the third option. Hope you understood whatever is discussed till now. And the next one is question number 7. Okay, here. This is one of the NCERT questions. Cos 2x minus cos 2 alpha divided by cos x minus cos alpha. See, we are aware of numerator, the angle is 2x as well as 2 alpha, whereas denominator angle is x as well as alpha. So what shall we do? Here is the method. We are going for the formula, multiple angle formula for cos 2x. There are 4 formula for cos 2x. The suitable one here will be 2 cos square x minus 1. Why do we particularly use the same formula? The denominator you observe, cos x, it is in terms of cos x, right? So the other formulae, one is it is in terms of tan function, the other one it is in terms of sine function, one more it is in terms of cos as well as sine. So the suitable one here will be 2 cos square x minus 1. And the next term is minus cos 2 alpha, which is 2 cos square alpha minus 1, using the same format. So here it is cos x minus cos alpha dx. So let us simplify it. Here we can cancel this minus 1. On opening the bracket, this will be plus 1. Negative into negative, it will be positive. So this plus 1 gets cancelled with this minus 1. So we can keep 2 outside, and we are left with cos square x minus cos square alpha divided by cos x minus cos alpha dx. Then we know what to be done in the numerator. Just go for the formula a square minus b square. So accordingly, this simplifies to numerator is a plus b, that is cos x plus cos alpha into a minus b, which is cos x minus cos alpha, divided by cos x minus cos alpha. It is already cancelled. And now we have the function for integration. 2 is the common term outside. And now integral of cos x dx. Integral of cos x dx will be sin x. And the next term, integral of cos alpha with respect to dx. Alpha is a complete constant. So integration of cos alpha, you treat it as a constant. So it will be plus x into cos alpha plus the constant c. So let us find out the option. The option will be 2 sin x plus x cos alpha. That will be here. It is option B. So here is the next question. It seems like just opening the bracket, is it not? What happens when you just open the bracket? First term it is okay, there is a ready-made formula for integration, but what to do with the next term? So let us do one thing. It is very simple, 1 minus cos x. And let us bring this cosecant square x to the denominator. When you bring into the denominator using reciprocal function, it will be sine square x. And our trigonometry is rich in formula. How do we represent this sine square x? See, just observe the numerator 1 minus cos x. We can relate it to 1 minus cos square x using the identity. Once again, 1 minus cos square x, we can write it as 1 plus cos x into 1 minus cos x. Students, you are listening, I believe. You are able to follow the classes, I think. Yes. You Ambicans are well disciplined. You will be eagerly waiting for the classes, offline classes to be started. We are not wasting our time. Let us learn things. Okay, 1 by 1 plus cos x can be written as 2 cos square x by 2 dx. So half remains half. 1 by cos square x will be written as secant square function. And it is one of the direct formula. So here, integral of secant square x by 2, we know it is tan x by 2 divided by the coefficient of x, that is half. Half gets cancelled with this and it will be tan x by 2 plus c. That is here option B. So when you are actually facing the CET paper, you can avoid all these steps and think, calculate in mind and reach to this step, or either 1 by 1 minus cos x, because you are familiar with sine square x as 1 minus cos square x. Moreover, the identity 1 a plus b into a minus b. Here is the next one. See, 1 divided by 1 plus root x. How to handle it? Just observe. Is it substitution or direct method? If it is substitution, what we have to do? Whether its derivative is present here or not. See, directly we can't relate it. You will have to see the options. When you see the options, we'll come to know it. What about integral of 1 divided by root x dx? It is equal to 2 times root x plus c. But is there a provision of relating that? No, because here it is added 1. Moreover, we don't have any of the options so. So let us try for multiplying and dividing by root x. When you multiply by root x and divide by root x, and the term is 1 plus root x dx. So let us think about the substitution. 1 plus root x equal to t. Immediately after substitution, we will have to differentiate it. 1 by 2 root x dx will be equal to dt. Then we will have to write everything in terms of t. So here we are with root x. How to rewrite root x using this expression or equation? So we are able to write it as t minus 1. And the next term is, in the denominator we have 1 plus root x. How can we substitute? 1 plus root x equal to t. And we are left out with dx by root x. Just consider this. What about dx by root x? Bring 2 to the right side. It will be 2 times dt. Is it not a simple simplification? See, we have to split it. The first term for integration will be t divided by t. It is 1. And the next term for integration will be 1 by t dt. And we know the integral of this function. We are integrating. Integral of 1 with respect to t, it is t. Integral of 1 by t will be log of mod of t plus the constant c. Let us go for the suitable option. What is our t? T is root of 1 plus root x. So that here it will be 2 times 1 plus square root of x minus log of modulus of 1 plus root x plus the constant c. So that option can be considered here, because here we can add the constant, complete constant 2 can be added with this constant and considered as a new constant. So hence, which will be the suitable option? 2 times root x minus log of 1 root x plus actually the constant c will be added to that c is considered as c1 plus 2. So this is the solution to the question 9. So next we have the next one that is related to the same root function itself. Here is the question, integral of square root of 1 plus root x divided by root x dx. So how can we handle it? See, we have already started with substitution. Let us think about substitution method. Which is the function for substitution? That is important. See, you can find 1 plus root x inside the root in the numerator. Do the substitution as t. Let us differentiate it. 1 by 2 root x dx will be equal to dt. Is it not dx divided by root x included here? So let us bring that to the right side. So dx divided by square root of x will be 2 times dt. So when we come back to this, it is integral of, see, mainly there is a root sign. 1 plus root x we have considered it as t, and dx by root x will be 2 times dt. And we know the formula. What about our integration of root t? We know it. It will be 2 divided by 3, t to the power of 3 by 2 plus the constant c. So which simplifies to 4 divided by 3. What is t actually? T will be 1 plus square root of x whole to the power of 3 by 2. That by 2 can be written as square root. So that option can be seen, 4 divided by 3 square root of 1 plus root x whole cube plus the constant c. So we have successfully completed the 10 questions, first 10 questions. Yeah. Here is another question. You can find the function, the integrand in the form of a to the power of x. When you read it in the form of a power x, here is, see, you can consider it as 2 to the power of, this function you treat it as t. So what is that you have considered at t? 2 to the power of 2 power x, it is equal to t. So as you substitute, the next work is differentiating. So let us differentiate it. 2 power x, treating it as a power x. So 2 power x, a power x into log of a will be 2. Further, differentiate this function using chain rule. What is derivative of 2 power x? Again it is 2 power x into log a. A is here 2. So that will be equal to dt by dx. That dx is written here. Let us come back to it. So here we wrote 2 raised to 2 power x is considered as t. Then what goes for dx? 2 power x into 2 to the power of x. See, here is the term. 2 raised to 2 to the power of x. Multiply to 2 to the power of x. We want dx here. Then what about this log 2 into log 2? Let us shift it to the right side. Divided by log of 2 whole square. So we get it here. This much dx can be dt divided by log of 2 whole square. Is it not the variable t? So what about log 2 square? It is a complete constant. We will put that constant out of integration. 1 by log 2 whole square is the complete constant. We have taken it outside. Then you know integral of a power x dx. What is integral of a power x? It is a to the power of x divided by log a. So here it is 2 to the power of t divided by log 2 plus the constant c. And so here you get 2 raised to t. What is actually our t? 2 to the power of 2 power x divided by how many times this log 2 is multiplied? Log 2 is multiplied 3 times. plus the constant c. Let us see whether the option is option C. Yeah, it is here. Okay. So here is the next question. So simple it is, very easy it is. You have to just identify where the function is, what its derivative is. So you can find exponential, but we don't have another exponential function as its derivative. Then we are left out with 1 by x square. We know that 1 by x is the function to be substituted. What's its derivative? Minus 1 by x square is equal to dt by dx. So we write it as minus 1 by x square dx is equal to dt. So we can come back to this. Let us substitute it in terms of t. This is e to the power of t is 1 by x. And we are left with dx by x square. Is it not here dx by x square? Minus sign to be shifted to the other side. So it will be minus dt. We know the answer. Minus sign will be minus. Integral of e power t will be e power t. So that is e to the power of 1 by x plus the constant c. That is here option B. So moving on to the next one, that is 13th question. So here is here is the one. 13th one, that is numerator sin x cos x, whereas in the denominator you can find 1 plus cos 2x. The fact is like this, usually derivative gets multiplied to dx. So which will be the function which is its derivative? Here is, if you treat 1 plus cos 2x or cos 2x as the function. So let me consider 1 plus cos 2x. Let us substitute it as t. Think about its derivative. It is 0. Derivative of cos function will be minus sin 2x. X has a coefficient 2, so multiply by 2. It is differentiation equal to dt by dx. We write it here. And do we have sin 2x multiplied to dx? Just see the numerator. Actually, there is not sin 2x. There is only sin x cos x. Let us use the formula. This will be minus, actually 2 into sin 2x is again 2 into sin x cos x. It is equal to dt. Let us write sin x cos x dx. That means 4 should be shifted to the right side. When shifted to the right side, it will be dt divided by minus 4. See, we got here. When you write it in terms of t, sin x cos x dx, from this sin x cos x dx will be dt divided by minus 4. And here we have named it as t, and nothing but integral of 1 by t. What about integral of 1 by t? Log of modulus of t. And t is actually 1 plus cos 2x. Is there an option like that? Yeah, it is here option A, minus 1 by 4 log of 1 plus cos 2x plus c. So coming to the next one, that is the 14th question. It is purely NCERT level. See, you have to identify the function as and its derivative. I told you the derivative will be multiplied, but it looks like divided. See, you see the function tan inverse of x. What's the derivative of tan inverse of x? It is 1 by 1 plus x square. So let us substitute tan inverse of x. It is equal to t. So 1 by 1 plus x square dx will be equal to dt. So here we write it so much. Is it not the derivative multiplied to this dx? Yes. So we can write it like this, integral of. This will be the function for integration cosecant. Tan inverse of x, we have substituted it as t. And we have dx by 1 plus x square. That will be dt. So it is in the list of formula. Integral of cosecant t dt. What about integral of cosecant t? It is log of modulus of cosecant t minus cot t plus the constant c. So is there the answer the same in the options? No, we don't have any of the options like that, is it not? So let us come back to the original variable x. What is actually t? Tan inverse of x equal to t. But nowhere you can find trigonometric functions inside log's function. So obviously they might have related it to the triangle. What does this imply? X is equal to tan of t. Now let us relate it to the right angle triangle. When the angle is t, opposite side will be x and the adjacent side will be 1. So we have the hypotenuse using Pythagoras theorem, root of 1 plus x square. So we are with cosecant t. Just let us go for cosecant t in this right angle triangle. What is cosecant t? Hypotenuse divided by opposite side. You are rewriting cosecant t as root 1 plus x square divided by x. Minus. Next function is cos t. So, it is cot t, and that cot t will be adjacent divided by opposite side. So it is 1 divided by x plus the constant c. Let us see any of the options matches this. Yeah, it is here option B, log of root 1 plus x squared divided by x minus 1 by x plus c. That is option B. Hope you got the method. We have substituted tan inverse of x is equal to t and the function reduced to cosecant t dt. So then next we have, actually none of the options had the function cosecant or cot. We related it to trigonometry using the triangle, identify the sides of the triangle and then wrote it in terms of x. That is all. So come back to this. Again we have faced a similar kind of question in your NCERT. But CET questions or competitive questions are a bit twisting, is it not? So obviously don't stick on only to that. If it is slightly changed, you will not be confused or distracted. See, here is the question. In our NCERT, similar kind of question we can see. When you consider the numerator, that is 3 cos x plus 2 sin x equal to t. But the derivative is, what is the derivative of this? Minus 3 sin x plus 2 cos x. So much dx equal to dt. My question is, can you find the same combination in the numerator? No, it is different, is it not? So let me give you a shortcut formula. If the integral is of the form a cos x plus b sin x divided by p cos x plus q sin x dx. See, NCERT questions are so simple, directly or its derivative or its proportion. That means multiple of the derivative will be there in the numerator. But here, if it is a different combination, if such thing appear, it can be considered as its integral will be ax plus b into log of denominator. Plus the constant c. Then how to find this a as well as b? A is actually given by cos coefficient multiplied, that is a into p, plus sin coefficient multiplied b into q divided by p square plus q square. Whereas b is given by, it is actually determinant like, see, aq minus bp. So it is aq minus bp divided by p square plus q square. Shall we try the same formula here? Okay, here a. In this, a will be, in the numerator cos coefficient it is 2. And what about b? B is sin coefficient in the numerator, it is 3. And what is our p? P is here denominator cosine coefficient 3 and q will be 2, that is sin coefficient in the denominator. Let us evaluate a. A value, it is a into p, 2 into 3, plus b into q, again 2 into 3. So a will be equal to 6 plus 6 divided by p square plus q square. 3 square is 9 plus 2 square is 4, simplifies to 13, which is 12 divided by 13. Next we need to find out b. What is the formula in finding b? aq minus bp. A multiplied to q, that is 2 into 2, it is 4, minus b into p, these two multiplied, it is 9, divided by p square plus q square is already evaluated, it is 13. So therefore it will be minus 5 divided by 13. So let us search for the option ax. A value is 12 by 13. See, here is 12 by 13x plus b log of denominator. B is minus 5 by 13, log of the denominator, so much. So it is just as I explain it, need time, but when you are individually working within fraction of seconds, you can complete it. But provided you should not be confused with the coefficients a of cosine as well as sine function. So while doing the classes, I have given you the formula. You might have noted it. Okay, here is the next one. Yeah. The next one, here it is 16 divided, 16th one, 1 divided by root x plus x root x. So it is simple and easy. We can take square root of x outside. So it will be 1 plus x dx. So here it is integral of 1 divided by root x into 1 plus x is rewritten as root x square dx. So let us come back to the substitution fact. Is it not root x equal to t? Then what about the derivative? 1 by 2 root x dx will be equal to dt. So this integral can be rewritten this way. 1 divided by 1 plus root x square will be t square, and dx divided by root x from this equation, it will be equal to 2 times dt. That is dx divided by square root of x will be 2 dt. So here you can write it as 2 times dt, and this is the standard formula. Integral of 1 by 1 plus t square will be tan inverse of t. So it is nothing but 2 times tan inverse of square root of x plus c. So question number 17. So here a number of functions are included: trigonometry sine, inverse trigonometry tan inverse, x to the power of 4 algebraic functions. You have to wisely think which will be the function for substitution. So here let us think about this function, that is the function inside trigonometry as substitution. Tan inverse of x to the power of 4 equal to t. You know derivative of tan inverse of x, 1 divided by 1 plus x square. As it is x to the power of 4, when squared it will be x power 8. Let us apply the chain rule and derivative of x power 4. What about it? 4x cube. So much dx will be considered as dt. So when coming to this, let us try to express the same function in terms of t. Integral of, let us concentrate on this function trigonometry sine. Sine, inside there is tan inverse of x power 4. We have substituted it as t. And we are left with x cube dx by 1 plus x square. Let us go for x cube dx. X cube into dx divided by 1 plus x to the power of 8. So here extra part is multiplied by 4. We will shift it to the right side. It will be dt divided by 4. That's all. So here it will be dt divided by 4. So 1 by 4 is the constant. Integral of sine function, we know it will be minus cos t plus the constant c. Let us replace the t suitably. That is minus 1 by 4 cosine function, and here it is minus cos tan inverse, because t will be tan inverse of x power 4 using that, and minus cos tan inverse of x power 4 divided by 4. That is option A. So let us come to the 18th one. So here we have integral of cosecant x minus sin x. Trigonometry identity will be cosecant square minus cot square, but instead it will be sine. So let us think about what alternative is there. Cosecant can be written as 1 by sin x minus the next function is sin x, so much dx. So we can simplify it inside the root. Let us find the combined denominator of this. It will be sin x, and the numerator simplifies to 1 minus sin square x dx. And you know 1 minus sin square x, which will be cos square x. So you can write it as integral of square root of cos square x divided by sin x dx. And root of cos square x simplifies to cos x divided by square root of sin x dx. Now do the substitution sin x equal to t. When you do the substitution sin x equal to t, we are with cos x dx will be equal to dt. So here cos x dx is dt, and this is root of t. Root of sin x will be t, which will be integrated using the formula 2 times root of t plus the constant c, and let us substitute t. T is sin x, so it is option A, 2 times root of sin x plus c. So 19th one. It is a simple one. So we'll have to identify the function as well as its derivative. So here is the function 3 plus 4 cos x. But what is actually the derivative of cosine function? It will be minus sine. But is minus sine function actually included? Yes. Sine 2x. What is the expansion of sine 2x? It will be 2 times sine x into cos x. Then the denominator, it will be 3 plus 4 cos x whole cube. Let us think about the substitution that 3 plus 4 cos x equal to t. When you do the substitution 3 plus 4 cos x equal to t, minus 4 sin x dx will be considered dt. We are with sin x dx. What about our sin x dx? Sin x dx will be dt divided by minus 4. Now, is it not cos x an extra function here? So let us try to write what is cos x from this. When you keep 4 cos x here, we can transform this 3 to the right side. It is t minus 3. So we can write cos x equal to t minus 3 divided by 4. Let us do the substitution in this step. So we get 2 will be the constant outside. We are substituting cos x using this function, that is t minus 3 divided by 4. And we are left with sin x dx in the numerator. Sin x dx will be dt divided by minus 4. So that dt divided by minus 4. And we have 3 plus 4 cos x cube. That will be nothing but t cube. So divided by t to the power of 3. Now we need to simplify that, rearrange it. That's all remaining. When you rearrange, see, we can cancel it. When you cancel it, here it will be minus 1 by 2 into 4, it will be 8. After cancellation, this will be 2 multiplied to this. And we are left with t minus 3 divided by t cube. Let us split this function. On splitting, it will be 1 by 8. The first function will be t divided by t cube. This after cancellation it will be 1 by t square minus 3 divided by t cube. Now all the terms are ready for integration. We have ready-made formula. Minus 1 by 8 is as it is. 1 by t square integration will be minus 1 by t. Now here minus 3 is the constant. Consider it as t to the power of minus 3 in the numerator. And use the formula t power n or x power n integration. Using that, it will be t to the power of minus 3 plus 1 divided by minus 3 plus 1. And now you add the constant and simplify, that's all. So the first term, on opening the bracket, it will be negative, negative, it is positive. So it will be 1 by 8 into t. Or else we can keep the negative sign outside. So you have 1 divided 1 by 8 will be outside, and negatives taken outside 1 by t, plus the next term here it will be 3 divided by minus 3 plus 2, which simplifies to minus 2. So 3 divided by minus 2 into t to the power of minus 2 plus the constant c. So it is 1 by 8. It is outside, and let us rewrite that t. That t will be here 3 plus 4 cos x minus 3 divided by 2. This can be written here, t square in the denominator, 3 plus 4 cos x whole square plus the constant c. So that is found in some of the options that we get here, 1 divided by 8. We have to take back to outside. Let us go for some error. Here it will be 2 is the constant. After cancellation you got it as 2, 1 by 8. Let me check it. Here it is sin 2x is written as 2 sin x cos x dx, and sin x dx is substituted dt divided by minus 4. And 2 is the constant outside, and we have cos x will be t minus 3 divided by 4. It is written here, and we are with 3 plus 4 cos x is t to the power of 3. When simplified, here we get 1 by 8 will be the constant outside, minus 1 by 8. First term will be minus 1 by t square, and the next term will be 3 divided by t cube. And on integrating it will be minus 1 by t, and here minus 3 is the constant. Consider it as t to the power of minus 3. On integrating we get it as t to the power of minus 2 divided by minus 2. So on simplifying, we can take this 2 outside. On taking that 2 outside, it will be 1 divided by 16, and there is no 2 here. We will multiply by 2, and it will be 2 divided by 3 plus 4 cos x minus 3 divided by 3 plus 4 cos x whole square. And let us go for that option. It is here it is there, 1 divided by 16. Okay, we need to find LCM and simplify it. When you find out the LCM and when you simplify it, here it will be 1 divided by 16. Combined denominator will be 3 plus 4 cos x whole square. So we will have to multiply 2 into 3 plus 4 cos x, which simplifies to 6 plus 8 cos x. That is, here the denominator will be 3 plus 4 cos x. Here it will be 3 plus 4 cos x whole square. Combined denominator is 3 plus 4 cos x whole square. So we need to multiply and divide the first term by 3 plus 4 cos x. So 2 multiplied to 3 plus 4 cos x will be 6 plus 8 cos x. And the next term it is minus 3 plus the constant c. So here 6 minus 3, which simplifies to 3. So you will get the answer 1 divided by 16, 3 plus 8 cos x divided by 3 plus 4 cos x whole square. plus the constant c. So let us find that 1 divided by 16 and 3 plus 8 cos x plus this is the term, that is option B is the right option. You got it here, that is 3 plus 8 cos x divided by 16 into 3 plus 4 cos x whole square. So we have come to the 2 by 3rd of the question paper it is discussed. So we have 10 more questions, 10 to 11 questions to be discussed. Let us finish it soon. Yeah, here is the next term. It is so simple and easy. 20th one. Here we have log x function in the denominator. Its derivative 1 by x is also there. So let us substitute log x is equal to t. So 1 by x dx will be equal to dt. So coming to this, here it will be dx divided by x. It is considered as dt using the substitution. And this log x will be t. So it will be t cube. And we know integral of 1 by t cube. Write it as t to the power of minus 3 dt. On integrating we get it as t to the power of minus 2 divided by minus 2, which can be written as 1 divided by 2 times t square plus the constant c. So that here minus, there is a negative sign here, minus 1 divided by 2 into t is actually log x, so it is t square plus the constant c. So that is the solution to the 20th question. So here is the next one. So in the numerator we can find secant square x. Just think about whose derivative is secant square x. It is derivative of tan function. And is it possible to substitute tan x equal to t? Let us think. When you substitute tan x is equal to t, will it help you? So we will have to just think about what changes can be done. First, the initial changes we can do is property of log function. See, here it is log of tan x raised to tan x. We can write it as tan x into log of tan x. So now do the substitution. Log of tan x equal to t. Let us think about, if just you do the substitution tan x equal to t, it may not help us. Now if you substitute log of tan x equal to t using chain rule, 1 by tan x into derivative of tan x will be secant square x. So much dx will be equal to dt. Is it here? Yeah, it is here. Secant square x dx. So that will be dt divided by, divided by tan x. Secant square x dx divided by tan x will be dt. I substituted it as dt. And log of tan x will be our t. And you know the integral of 1 by t dt, which will be log of modulus of t plus the constant c, that is log of modulus of, again log t will be log of tan x plus the constant c. So here we have log tan x. So we are assuming the positive value of log tan x. So we need here log modulus symbol is avoided. So coming to question number 22. So we have e power root x, cos of e power root x divided by square root of root x. So if you only substitute root x equal to t, what shall we do with this e power root x? Let us think about e to the power of square root of x equal to t. So derivative of exponential function will be exponential e power root x. Now using chain rule, differentiate this root x. It will be 1 by 2 root x. So much dx will be equal to dt. So we are with cos of this function will be t, cos t, e power root x dx by root x, e power root x dx by root x, extra thing is 2 divided by 2, shifting to the right side it will be 2 multiply 2. So e power root x dx divided by root x will be equal to 2 dt. So here it can be written as 2 times dt. So it is completely written in terms of t. Integral of cosine function will be sine. So sine t plus c. So it will be 2 times sine of e power root x plus c. Let us see for the options. Is there an option? 2 times sine e power root x plus c. So that is all. C is not typed in it. Now next is a easy question. Similar to it, we can find a question in the NCERT, but there it is not sine square, instead it is cos square. So there too it is a multiple choice question. So here the same content is used as in the previous case. Here we are with a function inside trigonometry. So let us think about substitution of x e power x equal to t. So we will have, it is product of two functions. So let us use product rule. U into v, you will use product rule u dash into v plus u into v dash is e power x. So much is equal to dt by dx. So for the same thing we have e power x is put out from the two terms. When e power x is taken outside, we are with 1 plus x and dx brought here, it is equal to dt. So the numerator turns to dt because e power x into 1 plus x dx, it is dt, divided by this function is sine square t. And do you know the integral of 1 by sine square? How to rewrite it? This sine square function, here it is to be written as 1 by sine square is written as cosecant square of t dt. And do we have ready-made answer for integral of cosecant square t? Yes, it is minus cot. So minus cot t. So the answer will be minus cot of t plus the constant c. Replace this t. T is x e power x. That can be found in option B, minus cot of x e power x plus the constant c. Then let us go for the function in this derivative here, because substitution part is such an important area. So we have cot function log of sin x. Using chain rule, as we did log of tan x that time, here we have log of sin x. Let us think it is equal to t. What is derivative of log of sin x? It will be 1 by sin x into derivative of that sin x will be cos x. So it is equal to dt by dx. So we have cos x by sin x is appeared as cot x. So we are with cot x dx. That cot x dx will be dt. Hope you got it. Cos divided by sin, cot x dx. Brought it to the left side, it is equal to dt. So here dt divided by log of sin x is here, it is equal to t. And we know the formula integral of 1 by t, which will be equal to log of modulus of t plus the constant c. So this will be log of modulus of function, that is t. T will be log of sin x. So that is found in option A. So log of sin x, that is found in option A. So last 6 more questions are remaining. Let us try to complete it at the earliest. Yeah, it is one of the tricky and easy questions. So how you handle it, that is very important. See, we have come across exponential and logarithmic functions. Is it not inverses to each other? So we rewrite e power 3 log x. That will be e power log x cube. And how to rewrite e power log x cube? That will be just x cube, because they are inverses to each other. And x power 4 plus 1 whole power minus 1. When brought to the denominator, it is x power 4 plus 1. So much dx. So this, when simplified, it will be x cube divided by x power 4 plus 1 dx. Let us think what may be the substitution. It is nothing but x power 4 plus 1 equal to t. When you do the substitution, x to the power of 4 plus 1 equal to t, it will be 4x cube dx equal to dt. So here we are with x cube dx. What is our x cube dx? X cube dx is equal to dt divided by 4. So here let us do the substitution. It is equal to dt divided by 4. 1 by 4 is a complete constant. We are keeping it outside. Divided by, this will be t, which simplifies to 1 by 4 log of t, and that t will be x to the power of 4 plus 1 plus the constant c, that which is found here 1 by 4 x to the power of 4 plus 1 plus the constant c is to be compulsorily added. So coming to the question 26. So here we are given a question that tan x is raised to the power of m divided by sin x cos x. Think what makes this for substitution. What is the derivative of tan function? Derivative of tan function is secant square x. But do we actually have secant square x in it? No. So what we need to do is we divide by we divide by cosine as well as multiplied by cosine function. So tan x power m is kept as it is. In the denominator you find sin x into cos x, divide the function denominator by cos x as well as multiply the denominator by cos x. So when that much is done, see we find sin x by cos x. Once again it will be tan x. So this simplified with the denominator tan x power m divided by tan x power 1. It will be tan x power m minus 1. And this 1 by cos square is considered as secant square x. Now you have the substitution to be done is tan x equal to t. When you do the substitution tan x equal to t, secant square x dx will be equal to dt. So this integral is changed to integral of t to the power of m minus 1. Secant square dx will be dt. You use the basic formula t power m minus 1. It will be t to the power of m minus 1 plus 1. So it is t to the power of m divided by m plus c. Replace that t. T is tan x. So we have tan x raised to the power of m divided by m, which is found here in option C. So hope you understood all the 26 questions discussed. Now let us come to the 27th question. So 27 and 28 are almost similar. So here we have square root of x square plus 1. So we are going to rewrite this x square plus 1. Root is written as power half in its index form. And we are with x to the power of 4. See, there is a small hint. You just try for terms inside the fractional power to be t. But will it work out here? No. If you do the substitution x square plus 1 equal to t, what is its derivative? 2x dx. But is 2x multiplied to it? No. So this is an extra part you will have to think. You just think about the simplification of term inside fractional power. See, we are with x square plus 1 inside fractional power half. Now let us keep highest degree of x square outside. When you keep highest degree of x outside, that is x square, when you put it outside, the first term become 1. Here no x square, multiply by x square, divide by x square, multiplied is taken outside, 1 by x square. And it is raised to the power of half. Use the fact a into b raised to half. So that will be a power half, x square raised to half, it will be x. And the next term will be 1 plus 1 by x square whole to the power of half. Now let us come back and substitute it here. X square plus 1 power half, that is simplified so. So I am replacing the last line x into, it will be 1 plus 1 by x square raised to the power of half and divided by x to the power of 4. We can cancel it. On cancellation, we can rewrite it like this. So we are able to write it as, we can rewrite it 1 plus 1 by x square whole to the power of 1 by 2 dx multiplied to 1 by x cube. Now we will have to think about the terms inside fractional power equal to t. When you do the substitution, 1 plus 1 by x square equal to t, differentiation is 0. Now x power minus 2, it is minus 2 divided by x cube is equal to dt by dx. We have dx by x cube. What about our dx divided by x cube? That will be dt divided by minus 2. Minus 2 is brought to the right side. So we are able to write it, that is integral of t to the power of half dx by x cube. From the last line, it is dt divided by 2. So we have to integrate it. This minus half will be there. This is t to the power of half. Integration will be 2 divided by 3 t to the power of 3 by 2 plus c. So there is a coefficient minus 1 by 3 after cancellation. Let us go for the option with coefficient minus 1 by 3. Here is the coefficient minus 1 by 3 and t is 1 plus 1 by x square, 1 plus 1 by x square to the power of 3 by 2 plus c. So that is the answer. So that is found in option C. Next, we are moving on to the next question, that is 28th one. It is almost similar. It is a question from KCET 2025. Here is the question. Think in the same way how we have worked out question number 27. So, is it possible x power 4 plus 1 equal to t? Never. It is not possible because there is no x cube multiplied to dx. So let us plan for taking the highest degree of x outside from the fractional power. The highest degree of x is x to the power of 4. When you keep x to the power of 4 outside, the first term become 1. What is the next term? Plus 1. It will be 1 by x to the power of 4. So what is x power 4 raised to 3 by 4? It will be x to the power of 3. 4 and 4 cancel and it will be 1 by 1 plus 1 by x power 4 whole to the power of 3 by 4. So here we can rewrite like this, dx divided by, it is dx divided by x square will be as it is. In the denominator I simplified this function. That function is simplified to x cube into 1 plus 1 by x to the power of 4 to the power of 3 by 4. Now this x square into x cube multiplied, it will be x to the power of 5. Now let us think for the terms inside fractional power equal to t. As in the previous case, when you do the substitution of terms inside fractional power equal to t, you get 1 plus 1 by x power 4 equal to t. So minus 4 divided by x power 5 dx will be equal to dt. Treat it as x power minus 4 in the numerator. Then differentiate using the formula x to the power of n. So you get this much. We are with dx divided by x power 5. Bring minus 4 to the other side. Minus 1 by 4 dt. So on substituting it here, this will be dt divided by minus 1 by 4. And here this is t to the power of 3 by 4. Let us integrate it. Here minus 1 by 4 is the constant. When you assume it in the numerator, it will be t power minus 3 by 4. So it will be t power minus 3 by 4 plus 1 divided by minus 3 by 4 plus 1. So let us add the constant c. So we have this is minus 1 by 4 will be the constant. You know 1 minus 3 by 4 which will be 1 by 4 divided by again 1 minus 3 by 4 will be 1 by 4. This 1 by 4 cancel with this 1 by 4. Now we are with minus t power 1 by 4. And you know t is 1 plus 1 by x power 4. So the answer will be minus t power 1 by 4. That t power 1 by 4 is written like this. Here, this C is the option because minus. See, we are written 1 plus 1 by x power 4 whole power 1 by 4. See, simplifying, on simplifying this, it will be minus of, after multiplying x power 4 plus 1 divided by x to the power of 4 whole power 1 by 4 plus c. So this is the extra part. That is extra simplification will be here. Okay, that is solution to question number 28. And next we have 29th one. Yeah, it's here. Let us think about the substitution of sine square x. So when you do the substitution sine square x is equal to t, we get using chain rule 2 into sine function. Derivative of sine x will be cos x. So that much dx will be equal to dt. So when you come back to this function, it is integral of e power sine square x we treated as t, so e to the power of t, and sine 2x dx, 2 sine x cos x will be sine 2x, so it is sine 2x dx. It is equal to dt. So we write so much as dt. The answer will be e power t plus c, that is e power t will be sine square x plus the constant c. So finally we are coming to the last one, that is 30th one. So by that this can be wound up. So once again it looks like the question from partial fraction. Numerator is of x square degree 2 and denominator is also degree 2. But it is quite simple. We have added and subtracted in question number 1, I think. So let us try for the same method. See here 1, there is minus x square. So let us add 1 as well as subtract 1, because this x square, with the x square we had 1 added to it, is it not? But the sign may be negative. Let there be minus 1 with that. That is why we are subtracting 1 and adding 1. So minus x square divided by 1 plus x square dx. So we are going to split it. The first function 1 plus this one, it will be 2. From the next two terms, that is third and fourth term in the numerator, we keep the negative sign outside. So it will be 1 plus x square. And it is divided by 1 plus x square dx. We are trying to bring 1 plus x square in the numerator. As the sign of x square was negative, we subtract 1, then we add 1. That is all. Now we are going to split it. It will be 2 divided by 1 plus x square minus 1 plus x square divided by 1 plus x square, it is 1. So much dx. You know, integral of 1 by 1 plus x square, it is tan inverse of x, and integral of 1 dx, it will be minus x. So here is the answer, 2 tan inverse of x minus x. The first term integrates to 2 tan inverse of x and minus integral of 1 dx will be x plus the constant c. So it is a vast topic. There are number of questions. So we have just opted 30 questions. I made an attempt to solve it to you. Hope you understood. So we will hope for the best. That we are waiting for the offline classes. You are to be in the classroom. Yes, by this I wind up. We will go for the next rest of the sessions. Thank you.
Hello students, welcome to the second session, and in this session we'll be discussing about the chemical kinetics CET concepts. Okay, so let us start the topic. Now one might be knowing it, what is chemical kinetic branch is all about, isn't it? So it is the chemistry or branch of chemistry which deals with the rates of the different reactions. Am I right? Yeah. Then factors affecting these rates, that's also very important. Then the mechanism. Factors affecting in the sense we'll be learning about the mechanism of the different reactions. Am I right? Yes. So thereby, let us begin the topic. First point to be answered here, or question to be answered, is rate of a reaction. Am I right? So what is the rate of a reaction? Rate of a reaction. Okay. So now, rate in the sense it is a change in the molar concentration of any one of the reactants, or it could be products, with a unit time. So how the rate of a reaction changes with respect to the time, that is defined as rate of a chemical reaction. So generally what we learn at the beginning is differential form of the rate of the reaction. So the differential form is given by d by dt of. Am I right? So consider a reaction where reactant R giving product P. So for this reaction, the differential rate equation is d by dt of the concentration of the R. Is that right? Reactant concentration to be known. So that is called as rate of a reaction. And when I say this, it is called as instantaneous rate. So there are two types of rates. One is average rate, the other one is instantaneous rate. So what is the difference between these two types of rates? Hope you learnt in theory. The average rate is nothing but change in concentration of the reactant. Am I right? But at a larger time interval. So 1 hour, 2 hour, you need to monitor the reaction mixture. So what exactly the concentration change, that to be noted down. So in that large time interval, the change is known as average rate. However, for all practical purposes, we require instantaneous rate. So with respect to each minute, what is the change in the concentration? That is actually needed as an experimental part of this chapter. Is it okay? So henceforth in the entire chapter, whenever rate term comes, it is instantaneous rate. We need not separately mention it as rate instantaneous. Just R if you write, you have to understand that it is an instantaneous rate. Whereas if the purpose of the question is to calculate average rate, then they have to mention it. Calculate the average rate. In the question paper, that particular thing will be mentioned. Otherwise, default it is instantaneous rate. For such type of reactions, R giving P. Reactants could be many, there need not be only one of the reactant. You can take many reactants over depending on the reaction. So this is the first point to be remembered. Instantaneous rate equal to d by dt of reactant concentration. Is that fine? However, when the equation comes of this type, A moles of A upon reacting with the B moles of B to give products. How could be, rate could be written, products. In such cases, the rate could be written as R is equal to, with respect to each reactant or product, you can express the rate. So I'll be taking only here reactant. So R is equal to d by dt of concentration of A. Right? That is equal to d by dt of concentration of B. Now having said that, the reactant concentration with respect to time, it is decreasing. So that must be indicated. Therefore rate is equal to minus, or negative sign has to be considered. Right? Here also is the reactant, so minus. Whereas the number of moles of A and B are not same here. Am I right? So therefore that part also to be included. So whatever stoichiometric coefficient comes, you need to divide that. So therefore this is 1 by A into, right, the negative of d by dt, or I will write that in a different manner here. Yeah, here it is. So minus 1 by A into d by dt of concentration of A. That could be equated to that of B, reactant B. In what way? Here it is. Minus 1 by B into d by dt of concentration of B. So this is a rate for this type of reaction. Suppose if I include product, if I change the product, right, notation as C moles of C and d moles of D. Can you connect this to the rate? How? That is also equal to, tell me, plus 1 by C d by dt of concentration of C, and further plus 1 by d by dt of, tell me, d by dt of concentration of D. This is how the entire rate for the given reaction could be written. Very important in KCET. Quite a number of times the question was asked based on this type of reaction. So they will specify 8 moles of A plus 3 moles of B, giving 1 by 2 moles of C and 4 moles of D, for example. So you need to mention those stoichiometric coefficients. Fine. So important concept under first side heading, that is rate of a reaction. Yeah, hope you followed it. Next, the important part, the negative and positive sign. What does they imply? The negative sign says that reactant concentration with respect to time is decreasing, whereas positive sign indicates rate increases with the time. So very important conclusion from the sign to be understood. Okay. Next, put a graph of concentration versus time. That's also one more important concept. Graph will be given which one is correct for rate of a reaction. That question is possible one. So let us put the graph. Here it is. So what are the variables? Concentration and time. So I'll take concentration along y-axis. So let me write a reactant concentration as R and time T. So what is the unit of concentration? You know it, mole per liter, molar concentration. One more thing, that square bracket indicates, we learned it in theory, indicates the molar concentration. Then time, let this be in seconds. Fine. So if you plot a graph, as time passes, the reactant concentration, as you know, should decrease. Am I right? Because reactants are consumed in order to produce the product. So therefore, that is indicated like this. So reactant concentration with the passage of time is decreasing. Whereas what happens to the product concentration? It should increase, right? It should increase. So if I include both product and reactant, in one graph I can draw that, but it is only for reactant, therefore it is decreasing. Whereas reversible reaction, if you take, product also at one point of time will become a reactant. Therefore, I can draw both the graphs. So product, if you want to draw, go for product concentration, and product concentration should increase. So the same graph I can write for product. See, like this. Put product as a P, and again it's mole per liter, and this is your time, which is in seconds. So product concentration, initially products nil actually, right? None of the products. Once you mix the reactant, then the product formation takes place. So this is the nature of the graph which you get for products. Product concentration increases. You can club together these two graphs, right? And equilibrium constant also to be, could be drawn from these two graphs. Fine. Now let's put a graph of rate versus time later. It depends on the another factor called order of a reaction. So generally we can't write rate versus time graph. Okay. So let us see later. This is about the initial point. Next, let us write a unit of this. Unit of rate. Unit of rate is mole per liter per second. Can you tell me why it is so? Because you have written a formula, d by dt of concentration term. So numerator there is a concentration term which is mole per liter, and denominator there is a time. So when it comes to numerator, per second. So irrespective of the order of the reaction, this is the unit for rate. It doesn't change for zero order, first order, or something like that. It is a constant one. However, if the reaction takes place in gaseous phase, then you have got one more unit, right? That is nothing but partial pressure becomes the concentration term in the gaseous phase. So partial pressure unit has, right, we have learnt in the other chapters, is atmosphere or bar unit. So thereby the unit becomes atmosphere per second or bar per second in the case of gaseous phase reactions. Okay. So with that, let us enter into the next concept, the factors affecting these rates, right? Factors affecting the rates. Shall I? Yeah. What what are the factors which governs? Factors affecting the rate. Of a reaction, rate of a reaction. Yes, mainly 3 factors to be learnt in detail, and that's what the 80% of this chapter is. So that is, first one, concentration, right? Concentration of what? Reactants. Concentration of reactants. And mind you, it could be partial pressure as well. Partial pressure in case of gases. So gaseous phase reaction, if you opt, or if it is given for us, then in place of concentration one has to take the partial pressure term. Fine. So detailed study is required about the effect of concentration. Let us move to that. So first point under effect of concentration is the rate law. Am I right? So we have studied it, that rate law. What actually it is? The rate law, which states that rate of a reaction is directly proportional to, so take a reaction, for example, again what we have stated earlier, A moles of A, B moles of B, giving C moles of C and D moles of D. Good. Now in such type of reactions, right, rate is proportional to, it is proportional to concentration of A to the power some X and concentration of B to the power some Y. This is what the rate is all about, and how it depends on the, or vary with the concentration term. So now I can write rate is equal to, I'll remove that proportionality sign, rate is equal to some constant K into concentration of A and B, each being raised to the power X and Y. This is actually the rate law, which we call it as experimental rate law. Why do we call this as experimental rate law? Because it's not theoretical, as stoichiometric coefficient is different from the powers which are raised. So here X and Y term we have taken. Otherwise, in equilibrium chapter, we have come across this under the heading called law of mass action. In law of mass action, what we are doing is A to the power A and B to the power B we are writing. But it's a bit different from that. Experimental fact, this is based on experimental fact, where A and B need not be equal to X and Y. It could be at some cases, but need not be. All the cases it won't be true. Then how one can know that it is equal to A and B, power to be raised equal to A and B, or it is not equal to A and B? It depends on 2 types of reactions. Very simple. If elementary reaction is given, then what you need to take as the powers of these concentration terms is nothing but the A and B itself. What do you mean by elementary reaction? One-step reaction. How do we know that? It will be given in the question. As simple as that, isn't it? Elementary, consider an elementary reaction. So then you take same coefficient as a powers. If it is not given, then the information about the X and Y will be given. How many times the rate changes on doubling the concentration or tripling the concentration. If these informations were given, then we can get to know what is these powers, which must be raised in the concentration terms. Fine. Later on you realized, or you studied actually, right? What is the sum of these powers? Right? Is the order of a reaction. So in equation 2, right? In equation 2, X plus Y is called as N, the order of a reaction. Order of a reaction. So the definition goes like this. Order of a reaction is the sum of the powers of the concentration terms given in the experimental rate law, right? Or just the rate law, because rate law itself says that it is an experimental rate law. So thereby sum of the powers of the concentration terms in the experimental rate law is called as order of a chemical reaction. Got it? Yes. Now, what are the different orders available in our NCERT limit? 0 order, first order, then fractional order. zero order, first order and fractional order. Of course, for JEE and NEET concept if you study, then higher order reactions also, second, maximum third order reaction, and a general equations for these orders also to be studied. But NCERT limit is that we have to learn only zero, first order and fractional order reaction, plus one more gaseous first order reaction. How the formula for rate equation comes for gaseous first order reaction, those things to be learnt after this particular concept. Clear? So basically order, some of the characteristics are there for order. First one, order could be zero, it could be fractional value, am I right? Even at times it could be negative as well. So all the possibility are there for order. Secondly, it must be obtained through experiment only. Otherwise you should know whether the reaction is elementary or complex. The second part of the, second type of the reactions are complex reactions, where multiple step reactions, and in that slow step is a rate deciding step. So if these information were given, then without the help of experiment also we can solve the order concept. What order reaction could be obtained with this particular data. So thereby the first part, rate and the rate law. Hope it is clear to you. Yes. So one more term to be explained there. What is K there? Where K is called in the equation 2, rate constant. Good. Rate constant. Or it is also known as specific reaction rate. Earlier this term was used, a specific reaction rate. Specific reaction rate. Done. Now, what is the unit of K? Don't you think, guys, unit of K is depending on the power to be raised, because these are concentration terms. So it depends on the order of the reaction. So unit of K depends on the order of the reaction. So side heading next you write unit of K. In fact, it is better to use units of K, because depends on the order as we stated. So let us see what is the unit of K for zero order, first order and other order, higher order reactions. So generally, in general, the unit of K has a formula, is mole per liter whole to the power 1 minus n second inverse. So this is the unit which we must remember. It's a formula to get to know what is the unit of K. Mole per liter to the power 1 minus 1 into second inverse, where n is the order of the reaction. Please make a note of it, where n is the order of the reaction. So if you consider a zero order reaction where n becomes 0, it is just mole per liter per second. So very important question which was asked in many times in KCET. What is that order of the reaction which has same unit as that of the rate? It is a zero order reaction, because rate unit is mole per liter per second. It's a constant one irrespective of order. Only zero order reaction has the same unit. So therefore next point you write down, zero order reaction has same unit for both rate as well as rate constant. Zero order reaction has same unit for both rate as well as order of the reaction. Rate constant, rate constant. Fine. Suppose the gaseous phase reaction is given, then you know it, isn't it? Here atmosphere to be replaced. Atmosphere to the power 1 minus 1 second inverse for a gaseous phase reaction. So with this, let us move to the second concept of this chapter, that is called as molecularity. So next one, molecularity. Molecularity of a reaction. So bit different from order, this particular term is molecularity of a reaction is the total number of reacting species taking part in a elementary reaction. Not enough. They must collide simultaneously. This is very important. There should be a simultaneous collision in elementary reaction. So in that collision, how many molecules are taking part? That is its molecularity. Say for example, if you have 5 molecules, need not be all these 5 molecules are colliding with each other at a time. After 2 molecules involving in collision, third molecule will come and hit. So this won't be called as simultaneous collision. So how many molecules are, or species, in the sense need not be molecules always, it could be atoms or ions, right, or molecules. So how many species are involving in such a simultaneous collision? That is called as molecularity, and that should be an elementary reaction. So one difference you noted down, in the case of order, it could be complex or elementary. Whereas in the case of molecularity, it is only elementary reaction. This term is applicable for elementary reactions alone. Molecularity has got no meaning for complex reactions. Okay, so thereby molecularity is a simultaneous. 2 important key points, key words it should be written in the definition. Okay, it is simultaneous collision, then elementary reaction. So that's what they did, right? Makes the molecularity and order as different. Fine. So there is a statement in NCERT which says that molecularity of a reaction cannot exceed 3. At the maximum you have got a termolecular or trimolecular reaction. What does it mean? Maximum probability of molecules involving in simultaneous collision, isn't it? It is 3. More than 3 at a time won't come and collide with each other. This probability you are speaking. So give reason type of question you can get, or assertion reason type, or statement type. Which one is correct, which one is wrong. So if we have got unimolecular reaction, molecularity 1. We have got bimolecular reaction where molecularity is 2, and at the maximum we have got ter or trimolecular reaction. More than 3 molecularity is very rare. So we are not saying it is not there, but at this level we have to understand this. There is a maximum molecularity as 3. There is molecularity also cannot be 0, because one of the theories says that only after collision there is a product formation. So if you have a complete chemical reaction, means where reactants are giving product, then there should be collision. So therefore it could be 1, 2 or 3. Molecularity 0 is not possible, whereas order could be 0. So you can make all these points as a difference between order and molecularity. Fine with that? Yes. So please understand why molecularity cannot exceed 3. Then the proper answer is this, because simultaneous collision between more than 3 species molecules are less probable. Okay, so there is very less probability of more than 3 molecules involving in simultaneous collision. These sentences to be, these keywords to be there. Same sentences will be there as options in MCQs. So please do remember this. Fine. So next term to be learned is pseudo, right? First order reaction. First order reaction. Many times again the questions were framed on this. Even this year you can observe in one of the paper. Pseudo first order reaction. Okay, what is that? Pseudo meaning false. False first order reaction is not actually the first order reaction, but you can convert any other order reaction, in fact higher order reaction, into first order reaction. So there lies a common point, how to convert higher order reaction into lower order, right? By varying the concentration. This is called as relative concentration. So when you take one of the reactant concentration in excess out of 2, the rate depends only on the other reactant concentration which is present in less amount. So see here, I'll take the example of inversion of cane sugar in acidic medium, C12H22O11, right? Add water, H2O, in the presence of acidic medium, H+. Now you know the products, C6H12O6 plus C6H12O6. So which are nothing but glucose and fructose. So in water aqueous medium. Fine, no? Yeah. Now, to prepare the solution of glucose anyway, so is also in aqueous medium. Now what I do is, I'll take around, no, exactly 1 mole of the sucrose. 1 mole of the sucrose. And I'll take very large amount of water, say for example 100 moles. So let this be 1 mole and this be 100 mole. Now the reaction takes place in 1:1 ratio. Will you agree with me? 1 mole of the sucrose will take up only 1 mole of water. If I take only 1 mole, perfect reaction, because the rate depends on the concentration of both. So second order reaction it is. Is that fine? Second order reaction. Whereas if I take this water as excess 100 moles compared to sucrose, water is in large excess, I must say. So thereby only 1 mole out of 100 mole will be utilized for this hydrolysis process, remaining 99 moles after the reaction. Does it make any difference? Initially 100 and after the reaction 99 moles. So change of course is there, but it is negligibly small. So the water concentration even after the reaction is retained almost as it is. Therefore it doesn't affect the rate of the reaction. So we can write rate is equal to rate constant into concentration of C12H22O11 to the power 1. In fact, I would have been written H2O to the power 1 as well. So some of the powers will become 2, second order reaction. Since this change is negligible, right, we are writing almost water concentration remained as it is. So its effective, right, its effect is nil. So thereby it depends only on the reactant concentration, that is sucrose. So first order reaction. Actually it was not a first order reaction, but by taking the one of the reactant large excess, or by taking, say for example there were many reactants, 3, 4, right? In such cases take all the reactants in large excess except one. So one which is maintained at a perfect, right, concentration, the other you take it in a large amount, all those reactant concentration doesn't affect the rate. So such a reaction is called as pseudo first order reaction. 2 important reactions to be remembered. One is acid hydrolysis of sucrose, that means inversion of cane sugar. The second one is ester hydrolysis, that also in the acidic medium. So these 2 are the famous examples for pseudo first order reaction. Again, theoretical concept to be remembered. Fine with this? Yes. Next side heading which we need to learn is integrated rate equation, right? Fine. So integrated rate equations. So till now we have studied about the theoretical aspect of this chapter. Now the mathematical steps will come, formulae. So out of integrated rate equation we need to learn zero order and first order. So let us write first one, A, zero order reaction. So integrated rate equation for zero order reaction. So I am not taking up the derivation part over here, just right, revising the formulae which will come across in this concept. So what is the rate constant? K is equal to 2 important forms you remember for calculation purpose. K equal to good R naught minus R divided by T. So rate constant is equal to initial concentration, R subscript naught if you write, it is initial concentration, and that same reactant concentration after time T. So that's what the formula is. However, for drawing graph we can rearrange this and we can get the form of y equal to mx plus c. So reactant concentration R is equal to minus K into T plus R naught. The second form of zero order reaction integrated equation. So y is equal to mx plus c. Plot the graph of reactant concentration against time. So what is the advantage? Let us understand. So put a graph of this. Let me draw here. Fine. Along the y-axis, take the reactant concentration. Once again, unit is mole per liter. Mole per liter. And the time, seconds. Now in this case, we'll get a graph of this type. Fine. Now if you extrapolate this so that it touches the y-axis, then you'll come to know what is that. What is that? Initial concentration, right? So that is the advantage. And also one more thing, slope gives information about the rate constant of the zero order reaction. So here it is, the initial concentration R0, and once you find out slope, you will get the information about the rate constant. So this is how graphically we can compute, right, the rate constant for a zero order reaction. Slope k is equal to, slope equal to minus k, or k is equal to negative of the slope, what we get. So at times graphs will be given and you will be asked to find out the order of the reaction. So remember, for zero order, R versus T graph is this type, and if graph is given, you need to identify this as a zero order reaction. So concentration versus time, if you get a straight line with a negative slope, it is a zero order reaction. Fine. Immediately here itself let us compute its half-life period. Okay, so let us go to the half-life of this. Half-life period of what? Zero order. Right? So T half. Okay. So half-life period of a zero order reaction. What do you mean by half-life? It is a time in which initial concentration is reduced to half of its original value. Right? Say for example, if I start the reaction with 10 moles, 10 mole per liter, then to become 5 mole per liter, how much time it took? That is called as its half-life. So T half for a zero order, it is initial concentration R0 divided by 2 times the rate constant. Very important formula. So which clearly says that half-life of a zero order is directly proportional to the initial concentration of it and inversely proportional to the rate constant. Important conclusion to be remembered. Fine. In some of the private authors' book, you can see this R0 as A, initial concentration, small letter A they will give. So this could be written as T half is equal to A divided by 2K in some of the books. Notations are different, that's it. Now, T 100%, time taken to complete 100% of a zero order reaction is 2 times of its half-life in a zero order, because it depends on initial concentration. Remember, 100 moles if we start with, to convert that into 50 moles, the time is called as half-life. Will you agree with me? Yes. It depends on initial concentration, mind you. Thereby 100 got converted into 50. That means consumed 50 moles. In the next half-life, remaining 50 moles also to be consumed. Since it depending on initial concentration, so 50 will become 0 in one more half-life. That means time taken to complete the reaction is 2 times of the half-life. So this is the conclusion. So thereby we can substitute 2 into half-life, R0 divided by 2 times the K. So 2 get cancels. Thereby the 100% of a zero order reaction is nothing but R0 divided by K. Yes. So one more formula to be remembered. Let us go for the first order reaction. First order reaction. Shall I? Yes. So B, under integrated equation we are learning zero order, we learned it. Now first order. So first order reaction. Fine. What is the first order reaction? It is a reaction in which rate is directly proportional to the first power of the reactant concentration. So that power to be raised is 1. If it is so, then all such reactions are called as first order reactions. Fine. Now integrated equation we need to understand. So there are various forms of first order integrated equation. Mainly we need to know all these forms. First form of first order integrated equation is exponential form. Remember it? Reactant concentration R is equal to its initial concentration R naught into e to the power minus k into t. Equation 1. This is called as exponential form of first order integrated equation or first order reaction. Exponential form of first order. Fine. So as reactant concentration changes, or as time changes, what will happen to reactant concentration? Decreases, because minus k into t. How does it decrease? Exponentially. So can you put a graph for this? Was asked which among the graph is true for first order reaction. So here it is. So there are many graphs in first order. Understand all these things. So I have a concentration of the reactant R. I have time scale, right, along x-axis. Now as time passes, reactant concentration must decrease in any of the reaction, you know it in respect to the order, but in first order exponentially, right, changes. So exponentially, initially let it be maximum, so next decreases like this. Same graph which I have seen at the beginning also, right? Exponentially decrease. So that graph is true for first order. What next? Let us take the log, natural log first, then the log to the base 10. So if I write the second form, then it would be like this. Log of reactant concentration R is equal to so base E and ln term cancels, so 2.303 remains. Therefore it's minus KT divided by 2.303 plus log of R naught. I've skipped a step over there. Otherwise initially I should write ln R, that is equal to ln R naught minus KT. Then the conversion ln to log 2.303. Right? So log R is equal to that 2.303 I'll take to the right side in the denominator, minus k by 2.303 into t plus log R naught. So this is the second form or second equation under the first order integrated equation. So it's also of the form y equal to mx plus c, right? So we can put one more graph here. Yes, we'll do that. Important there. Slope formula was asked many times in CET, almost 4 to 5 times in last 10 years. So put a graph of, what is that? Graph of this time log, right? Log R against time t. See, slope term lies here, right? Slope minus k by 2.303. And y equal to mx plus c, so with a negative slope, same type of graph as we observed in zero order. What is the difference? Variables, right? There it was R versus t, here it is log R versus t, remember it. So the extrapolation of that will again give one more important information. Perfect. Now it is slope equal to minus k divided by 2.303. Whereas this particular point where it touches the y-axis, we get log of R naught. Log of R naught. The second graph under first order integrated equation. What next? Let us rearrange this. Okay, let us rearrange this. Let me get this 2.303 or minus k t divided by 2.303 on the other side. So the sign changes positive, and get this log R on the other side. Log R naught minus log R is log R naught by R, right? So that therefore third form of this is Kt divided by 2.303 is equal to log of R divided by R naught. Dear guys, in NCERT you have got the same equation and it was asked, it's y is equal to mx form. So your graph has to pass through origin. Am I right? So put one more graph. There are 4 graphs under first order. Okay. So this time, as I said earlier, is graph of log R by R naught. Right? Am I right? Or R naught by R? R naught divided by R it has to be. So please do change that. Yes. Log of R naught divided by log R. Put a graph of these two now. And as you know, straight line graph you will get. That's what it represents, this type of equation. Yes. And I can write the variables as log R naught divided by R on the y axis and the time t on the x axis. Observe this equation, dear students. So slope of this graph has to be k by 2.303. Earlier log R versus t, if you take the second graph, you had slope as minus k by 2.303. If you take the ratio of R naught and R and log of that, then this is the graph, and slope is going to be, slope is equal to k divided by 2.303. Numerical could be asked from these sections. The slope of the graph between log R naught by R versus t is found to be 2.3 into 10 raised to minus 2. What is the rate constant? So to that given value multiply 2.303. Suppose same question, log R versus t graph as a slope if it is given, then negative of that particular slope to be taken. Otherwise you will get the sign difference in the options. So be careful about this slope formula. Fine. Then finally the last form of this, where the numericals could be solved by using, tell me, k is equal to 2.303 divided by t log of R naught divided by R. As I said earlier, R naught is A, R is after some time remaining concentration, so A minus Ex could be taken. If a reaction completes 80% if it is given, started with 100%, right, 80% complete, so what is remaining? 100 minus 80, so A minus X is that. So same equation, sum of the private authors again have given it as k is equal to 2.303. Should be knowing it, right? 2.303 divided by t log of A divided by A minus X. X is a reacted concentration, A was the initial, so initial minus reacted is remaining. So that's what R is about. So these are the different forms of first order integrated equations. So next, moving on to half-life of this reaction. Okay, so side heading half-life. So we are learning now half-life of first order reaction. So T half is equal to, very important, 0.693 divided by K, where K is once again specific reaction rate or rate constant of a reaction. Okay, so what is the conclusion here? Half-life of a first order reaction is independent of R naught, that means initial concentration. It depends only on the rate constant, that also inversely. So it is inversely proportional rate constant and independent of the initial concentration. So irrespective of the initial concentration you take, 100 mole, 200 mole, 10 mole, doesn't matter. Half-life is independent of it. So the right important point to be remembered. So I can give one more form of it, that is ln 2 divided by k in the case of options, right? If ln 2 by k was there, then that has to be selected, because ln 2 is written as 2.303 log 2, right? Log 2 has the value of 0.3010, multiply by 2.303, you'll get the same answer, 0.693. So thereby these are the two different formulae, right, for half-life of a first order reaction. Hope it is fine. Now come back to that shortcuts which we must be, right, knowing it in CET while solving CET questions. Half-life, anyway it's known, so let me talk about these conversion factors. Imagine you have started the reaction with 100 moles. So to convert this into 50, the time, as I already told you, is half-life, T50, right? Now 50 will become in the next half-life, one more half-life if you wait for of this reaction. It is not zero. In this zero order it was zero, right? Because it was depending on the initial concentration. Now it doesn't depend on 100 moles what you took initially. It depends on 50 now, right? So it's half to be converted in the next half-life. So it will become 25. So further it is 12.5. Further it is 6.25. And it goes on like this, dear students. So here also T half, this also T half. Now 50% complete means remaining is 50%. Whatever written numbers are completed, right? So am I right? Or remaining? It's remaining concentration, right? So 25 is remaining. 50 it was in second half life, remaining is 25. So convert it further, 75, right, out of 100. So here completed time, if you ask, then it's 75% completion. This is 87.5%. It is 93.75%, and goes on like this. Therefore, the shortcut formula, time required for 75% conversion in first order reaction, here it is nothing but 2 times the 50% of that. Time required to convert 87.5% of first order reaction, 3 times the T50%. Remember this formula. Time required to convert 93.75% is equal to 4 times the T50%. Similarly, if you work out these things, then at the end you'll get time required to convert 99.99% of a first order reaction is 10 times the T50%. And I guess around 3 times after 2020 KCET, you had the numerical based on this formula. Okay, even in NEET I have seen this. T 99.9% or 99.99% equal to 10 times the half-life of that. So very important formula, shortest formula perhaps, right? Easy to calculate. 40 minutes something, they'll give the value. So multiply by 10, 400 minutes. You convert that into hours if options were in hours. So as simple as that. Fine. Finally, I'll wind up this first order equations with one more formula, that is amount of substance remaining. Say for example 5 or 10 half-lives were over. How many reactants, how many grams of reactants are remaining? Could be calculated with one more shortcut formula, that is amount of substance remaining after n half-lives, X is equal to its initial concentration R naught divided by 2 to the power n, where n is not the order, dear students, here, right? Don't get confused. It's not the order here. Number of half-lives. So how many half-lives is given? Just check it out. And to the power of that half-lives, taking the denominator, and initial concentration also will be given. So how much remains after so many half-lives could be obtained with this shortcut formula. Yes. Then half-life of any given reaction is proportional to 1 divided by initial concentration to the power n minus 1. Again, let this be known. To apply to different order, except first order, this general equation holds good. 0 order, put n equal to 0. right? R naught to the power minus 1, that goes to numerator R naught. We have stated zero order reaction half-life is directly proportional to the initial concentration, holds good. Second order, third order, irrespective of that order, this equation holds good. Okay, so important, two different time half-lives will be given, one reaction order will be given, the other could be asked. So what do you have to do? Take the ratio, no? Proportional sign cancels out, right? You'll get the order. So therefore such type of calculation also important in CET. Fine. So with this, let us enter into some miscellaneous formula, right? How to express rate for a reversible reaction we haven't studied. How to express rates for equilibrium reactions or simultaneous reactions. So these things to be studied now. So next side heading is reaction rate, or rate equation you can write there. Rate equation for reversible reaction. Reversible reaction. Okay. So consider a reversible reaction H2 plus I2 giving 2HI. Famous formation of hydrogen iodide reaction. Now, rate for this reaction R is equal to, rate law let us apply. For the forward reaction, let me write rate constant as K1. For the backward reaction, let it be K2. Fine, no? Yeah. So, for the time being, you don't consider the reversible sign. Okay? So, this is a forward reaction or one direction reaction. How do you express rate for this? R is equal to rate law. Right? So it is K1 into concentration of H2 to the power 1 and that of I2 to the power 1. As simple as that. But then the product formed is not stable. It has to come back. So your reactant earlier for the forward reaction is changing now. It's not a fixed one. You can't say that with the time reactant concentration goes on decreasing. It could increase also after certain, right, time of the reaction, isn't it? So thereby it changes. So what do you have to do? Minus. So this is a backward reaction which is occurring. For backward reaction, now you forget about K1 path, go to the K2. This is the reactant, isn't it? So you have to subtract the HI concentration, the power 2, square of it. So this is the rate law for reversible reactions. Very important. You write initially one direction reaction, then subtract the backward reaction, right, effect. And I have to write here the rate constant for it, isn't it? So it is a K2. I mentioned that. We need to consider that as well. So it is minus K2 into HI the square. Similarly, let us go to the parallel reaction, especially in organic chemistry while calculating the percentage of the products formed. We say 50% of product A, 25% of product B. How practically we can calculate is with the help of second concept. So please do write next as rate law for parallel reaction. Parallel or side reactions, byproduct formation if there, then you have to opt some different method. So let me take an example of parallel reaction. So which is a famous one we have studied in organic chemistry, haloalkane, right? A substitution reaction, nucleophilic substitution reaction, and C2H5Br upon reaction with the KOH nucleophile, right? There are two different products one can expect. Am I right? The first one, it could be a mere substitution. So if substitution takes place, will you write a product of this substitution? C2H5OH plus KBr. So let me indicate this as a path K1. Rate constant for this reaction is K1. Whereas side reaction, one more product is possible. Let that rate constant be K2. and the products possible, which are those? CH2 double bond CH2. I'm writing elimination, mind you, right? So alkyl halide with a nucleophile can undergo substitution as well as elimination. So if this is a possibility, then CH2 double bond CH2 alkene will get the other products KBr as it is plus what? H2O. So these are the two different pathways and products possible for this reaction. How do you find out now rate under such condition? Very important. So rate of this reaction, let me write R, is equal to same logic, right? Reactant concentration, only the decisive factor for rate. So let us write it. So consider first path. So it is K1 into, right, concentration of the C2H5Br. This is a reagent, so therefore we are not considering it. Or you take this in large excess, no? It works. Its concentration doesn't change. So therefore C2H5Br concentration. Now it's a side reaction. It's not a reversible reaction. Reversible, then we would have been written minus sign. It's a side reaction, therefore plus sign. Plus the K2 into, for the second path also reactant is same. So it is C2H5Br to the power 1. Now then, I can simplify this. Rate is equal to, tell me, K1 plus K2 into concentration of C2H5Br. With this, one can find out the percentage of product formed, how much of alkene is there in the reaction mixture or alcohol is formed. How do you do that? Simple. Percentage of, right, C2H5OH. I easily would have been written A here, product, percentage of A, percentage of B. That is also, in that way also we can simplify it, let it be. So percentage of C2H5OH is, can anybody? The denominator total rate, so that's K1 plus K2 into C2H5Br. In the numerator we have to take C2H5OH path, that is K1 into C2H5Br. C2H5Br concentration gets cancelled, so it's a mere ratio of K1 divided by K1 plus K2. So K1 divided by K1 plus K2 into what? Percentage 100. Simple. The rate constants will be given in the question, K1 and K2. You need to take the ratio, K1 divided by K1 plus K2. Can you tell me what is the percentage of alkene in this? Ethene formed is K2 divided by K1 plus K2 into 100. Very simple. So do complete that as well. Also, percentage of C2H4, I'll write the formula of it. CH2 double bond CH2 C2H4 is equal to K2 divided by K1 plus K2 into 100. So two important concepts out of NCERT you have come across, I guess, in this. Based on the PYQs, these synopsis, these concepts were selected. Fine. So with this, let us write the formula to calculate rate constant in the case of gaseous phase reaction. So next, for gaseous phase you write. For gaseous phase, do you remember? Rate constant K is equal to 2.303 divided by T log of initial pressure Pi divided by pressure of the reactant at time T. Pressure of the reactant at time T. And if a reaction is of this type, A plus B giving C. I think this was we have derived in theory. A gas plus B gas giving C. So in such cases, right, the denominator term becomes 2 times Pi minus Pt, where Pt is the total pressure. So need not be always this type of reaction. It could be 2A plus B, then the denominator term changes. Numerator remains same. So this could be obtained with the help of equilibrium concept, right? So you'll see such type of problems when worksheet being solved. Okay, so basically this is the formula, or denominator you can write pressure of the reactant at a time t. This also could be written in the denominator. For this type of reaction we have got here the equation. Fine. So with this, the first factor affecting on the rate constant, factors affecting on rate, the first factor is completed, that is concentration effect or effect of concentration. Let us move to the second one, it's temperature. How temperature changes the rate. Effect of temperature on rate. Effect of temperature on the rate. Okay, let us simplify as much as possible. Okay, for every 10-degree raise in temperature, we said rate gets doubled, right? So this is known as temperature coefficient, eta. So how exactly rate changes with the change in the temperature is denoted with the sign eta, which is temperature coefficient. So here it is. So eta is equal to rate constant at a given temperature, K at T, given temperature, divided by rate constant at 10 plus, T plus 10. So the T plus 10 has to come in the numerator, because always eta is more than 1. It says, a statement says that for every 10 degree there is a doubling of rate. So if you want to get the value more than 1 or 2, it has to be higher value, right? So Kt plus 10 divided by Kt is a temperature coefficient formula, or whichever I have written earlier, like that also you can write it. For that, see here, eta is equal to, if you want to write Kt in the numerator, then the denominator term should have been Kt minus 10 degree. Always numerator higher temperature rate constant to be taken. Okay, so therefore this is a ratio of rate constants at 10 degree higher temperature to the given temperature. So one of the exam it was so asked, temperature coefficient is the ratio of rate constants at 10 degree temperature difference. It's wrong. It's not 10 degree temperature difference to be seen. It is 10 degree higher temperature to the given temperature, or to the given temperature and 10 degree lower temperature. Difference means you can write this at the numerator as well, but that doesn't work, because your eta value will come down. It always increasing, right? Rate has to increase with the increase in temperature. That is the ultimate concept to be remembered. So therefore these are the two formulae which we can use for temperature coefficient. The term is new to you. You have not studied in theory. In theory only it states that for every 10 degree there is a doubling of rate constant. Fine. So how exactly? This is the one which, in fact, rate changes 2 to 3 times. It's not doubling always. It will be between 2 and 3. 2 to 2.5 also possibility. So therefore, temperature coefficient need to be defined. Fine. Next, how exactly it doubles, or why it has to double? You have learned through graph. Potential energy against reaction coordinate graph you have drawn in your theory part, and you said that whenever 10 degree temperature got raised, the number of activated molecules, or the molecules having energy equal or greater than activation energy, gets doubled. That is the reason why there is a doubling of rate. So once activated molecules got increased, obviously the product formation increases, right? Or the product concentration will increase. So that is the main point to be remembered. Why on doubling, why on increasing temperature by 10 degree, rate doubles if is asked, then your answer must be, whenever temperature is raised by 10 degree, the number of activated molecules gets doubled. What do you mean by activated molecules? Molecules having energy equal to or greater than activation energy. So again, activation energy to be studied. right? No, so one more term. So go to the Arrhenius theory in order to understand activation energy. So in the temperature effect, main point is Arrhenius equation and Arrhenius theory. So according to Arrhenius equation, rate constant K is equal to, so once you find out K, it could be connected to rate, because rate equal to rate constant into concentration, no? So therefore K is equal to a constant given by Arrhenius A into e to the power of minus EA by R into T. Again, the different forms of Arrhenius equations available is the first exponential form. One can plot a graph, isn't it? So K against 1 by T if you plot, or T. K and T variation, you should be knowing it, increases exponentially. K and 1 by T if you take exponentially decreases. So don't get trapped in the exams. Okay, so if I take a graph of K against T, then exponentially there is an increase in the value. So 1 by T if you take, then it is exponentially decreasing. Fine. Logarithmic form. Ln K is equal to minus EA by RT plus ln A. So plot of ln K versus 1 by T is a straight line with a negative slope, just like in 0 order and first order whatever we've seen. Slope differs, EA by R, with a negative sign. However, if you convert this into log K is equal to minus EA by 2.303 R plus what? Log of A. So now also you can plot a graph. So take log K on the y-axis and 1 by T along the x-axis. Then this is the nature of the graph what you're getting. Mind you, the slope is equal to JEE, NEET and CET. In all the examination you got questions in previous years from this concept, slope formula. So slope is equal to minus EA divided by 2.303 R. In 2026 January shift, there was a question in JEE based on this, and their slope was given, value was given, you are asked to calculate EA, but remember it's not log K versus 1 by T plot they have given. They have given it as ln K versus 1 by T. Then while substituting, be careful, minus EA by 2.303 is not there, it is only K. R. Perfect. Last, at two different temperatures. Got it, no? It's slope equal to minus EA by R. 2.303 should be avoided. Ln K versus 1 by T if you take. Finally, at two different temperatures. Log K2 by K1 is equal to EA divided by 2.303 R into T2 minus T1 divided by T1 into T2. This formula to be used. So you supposed to take a note here. Suppose if activation energy is nil, 0. Right? If activation energy is 0, then the entire right hand side becomes 0. So I have log K2 by K1 equal to 0. K2 by K1 is anti-log of 0, which is 1. So thereby K1 equal to K2. There is absolutely no difference between the two rate constants whenever activation energy is 0. So when EA is equal to 0, right, K1 equal to K2. Point to be remembered. Similarly, when temperature tends to infinity, very high temperature if you maintain, right, you can utilize this equation, or exponential form also you can consider here. When temperature tends to infinity, 1 by infinity is 0, e to the power 0 is 1, therefore K equal to A. Your rate constant is just a constant, that is Arrhenius factor. So when temperature tends to infinity, will you help me here? K is equal to A, remember it. So with this, two more concepts remaining. That is one, collision theory. Okay. Let us move to that, collision. Then effect of catalyst. How catalyst will alter the rate of reaction. So side heading you write collision theory. So under collision theory, you should remember two important factors. Okay. So formula for collision, rate in collision theory is K is equal to, or you can write rate, invariably we can use rate constant or rate. So rate is equal to a probability factor P, right? ZAB. What is ZAB? P is a probability. Let me brief about it. Probability. ZAB is a collision frequency. How many collisions are taking place between A and B per second per unit volume of the reaction mixture. Per second per unit volume, that is your ZAB. Both will be given, and the remaining is copy of Arrhenius equation, isn't it? E to the power minus EA by R into T. This is a formula given in the collision theory. So what are the criteria for effective collision? So a new term, effective collision. What do you mean by effective collision? All the collisions which are taking place between the reactant molecules need not to end with product formation. It need not be. There is a collision, but product formation is not taking place. Right? We can compare with in our day-to-day life also. Right? At times we read, but it won't be effective. Effective reading means tomorrow when you give exams, right, whatever read has to come, right? Not in the question paper I'm telling, right? In answer paper. So that is called as effective reading. So similarly, all the collisions might be taking place, but need not end up with the product because they are lagging in some of the points. What is that? The criteria what we are going to write now. So effective collision criteria. So first one, there should be sufficient energy in the form of kinetic energy as well. There should be sufficient energy which must be equal or greater than that of the threshold value. So there is a new term now, threshold energy. Minimum energy required, right, to take part in a chemical reaction is called as threshold energy. So therefore I can write sufficient high kinetic energy, that is threshold energy, equal or greater than threshold energy denoted by ET. For your information, what is threshold energy? If you want to know, then threshold energy is equal to it is energy of the reactant plus activation energy. So from which activation is equal to threshold value minus energy of the reactant. I'll back to it in graph. Let us see. Next, second criteria for effective collision, molecules should be properly oriented. It's not enough only if collision takes place, but also that collision must be effective. For that, orientation of the reactants are very important. Reactant molecules must be properly oriented. The best example available is, as mentioned in many books, it is a SN2 reaction. Right? In the SN2 reaction, orientation has to be proper, otherwise there is no product formation. Alkyl halide and incoming nucleophile should not be in the same direction because there is a repulsion. So the reactant nucleophile has to approach from the opposite direction to that of the leaving group, then only the product formation. That is what the proper orientation. So proper orientation. So these are the two very important criteria. One, equal to or greater than threshold energy. Some of the books will write this as a sufficient high kinetic energy. That is also fine. Then proper orientation. When these two things are there, then such collisions will result in the product formation. Fine. Now, let us write for two reactions the graphs. The first one I'll go for exothermic reaction. Very important, these graphs. The next one, let me take up the endothermic case. So along the x-axis, here I'll take up the reaction coordinate or progress of the reaction, and here let me go for potential energy or energy axis, potential energy and reaction coordinate. The nature of the graph will be bell shape, as you learned in theory. This is what the graph is. Now here I have energy related to reactant. Okay, so this is energy of the reactant, this is what energy of the product, and here comes the threshold energy. The difference between the threshold energy and reactant energy is known as activation energy. And you can connect this to thermodynamics as well, dear students. This difference I am telling you, right, is any idea? This is, can you make it out? Product energy minus the reactant energy is delta H, enthalpy of the reaction. So this is what delta H is. Now as you can observe here, product energy is a lower value, the reactant is a higher value, therefore the difference is negative. So delta H is equal to negative. What does it mean? Exothermic reaction. So this is the graph which is true for exothermic reaction. Having said that, in NEET, JEE, CET and all, reverse reaction, what is the energy of activation type of questions were asked. So when the reaction, exothermic reaction is reversed, you have to start from here, is the energy of the reactant this time, right? So you have to climb an extra height, you see, that is equal to delta H. Therefore, for reverse reaction, in the case of exothermic reaction, activation energy I will denote EA dash, which is more than EA. So how do you calculate it? For reverse reaction, let me say EA dash, activation energy, is equal to EA for the forward reaction activation energy plus delta H. Since delta H sign is negative as exothermic, if you write directly plus delta H, then it end up with having lower value than EA. But it is evident from the graph, isn't it? Just observe, this is the height to be climbed now, extra height. And I'll denote this as EA dash. So therefore EA dash is more than EA. In order to happen that, this modulus to be taken, right? Only magnitude to be considered. Next, for endothermic case, okay, this is for endo. How do you draw this graph? Reactant, right? Product is having more energy, so this is the nature of the graph for endothermic reactions. And one can write the activation energy. This height, what we are going to denote it as delta H. So here threshold energy, energy of the reactant, EA, delta H, which is the product minus reactant. Here is a product energy. So EP minus ER, which is equal to positive. So it is endo. Will you tell me now reverse reaction of this activation energy here? Right? Only this is the height to be climbed. So this I'll denote it as EA dash. Tell me now, EA is more or EA dash is more? EA. Therefore, you have to subtract delta H from EA in order to find the activation energy for reverse reaction. So if endothermic reaction is reversed, activation energy is less. If exo is reversed, activation energy is more. So for reverse reaction, EA dash equal to EA minus delta H. Anyway, their delta H value is positive, so needless to consider modulus, but let us have the similarity, right? In the formula, they have taken it. Finally, the effect of catalyst. Let's go to the effect of catalyst. So catalysts are those substances which enhances the rate of reaction without themselves undergoing any permanent chemical change. Temporary change could be observed, but permanently there is no change in their physical state or chemical, right, reactivity. So such type of substances are said to be catalyst. Suppose if added substance decreases or retards the rate of a reaction, then we call them as inhibitors or poisons, right? Fine. So now, how actually the catalyst will alter the rate of the reaction? The graph will make you, right, understand this concept. So let us go directly into the graph. There's a famous statement about the effect of catalyst. Let me give that statement later once we understand this graph. Okay. Again, the plot is about the potential energy against the reaction coordinate. So it's not new to you. And the pathway of the reaction, already we learnt it. So what is that? Right? The nature of the graph will be like this. So denote all those things which we have already marked in the endo and exothermic reaction case. So this is it. And this height we are referring as delta H. So I'll write ER, EP, and energy threshold ET. This is what the interested one, activation energy EA. Whatever I have shown here is the reaction pathway in the absence of catalyst. So without catalyst, this is how the reaction proceeds. So without catalyst, let me give that. Without catalyst. What happens when you add a catalyst? It has to start from same reactant, right? And it has to end up with same product. But the pathway differs. It's not the same route on which the catalyst added reaction is traveling, right? So it will be somewhat like this. End up with having same product. Now as a result, I can, right, write this as, let me show that difference. Here it is, the second graph. So this is EA dash. It is evident from the graph that the height which the reactants must be climbed is reduced or decreased. So thereby the famous statement goes like this: in the presence of catalyst, or catalyst will provide an alternate pathway for the chemical reaction. Alternate pathway means it could be reaction mechanism as well. Okay, alternate pathway for the chemical reaction in which activation energy is reduced. So catalyst will reduce the activation energy, thereby they will make the reactants to reach the product stage quickly. So it increases the rate of the reaction. Hope you understood. So the second graph which we have done is with the catalyst, right? So you take that as reaction pathway with the catalyst, or in the presence of catalyst. First one is without, the second one with the catalyst. So we have a very important information, EA dash is less than EA. So activation energy, if it is decreased, reactions fastens out, right? So that's what the chemical kinetics, CET level concepts. Hope you have understood. If not, read again. Right? There's only one solution which we have got, and the worksheet is uploaded in the Ambika app, so you can refer the questions from this chapter. For others, it will be given, distributed later. Thank you.
ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಾ? Good afternoon all. Welcome back to the afternoon session. So we will be beginning with the chapter Principles of Inheritance and Variation, right? So as an introduction part or as a synopsis part, I'm just highlighting the overall summary of this chapter, correct? So what are we discussing in this chapter is the first part of the chapter is Mendelian inheritance, right? So there we learn about Mendel's monohybrid cross as well as Mendel's dihybrid cross. So we call this type of inheritance as Mendelian inheritance, right? So in the monohybrid cross, we will be selecting, or the Mendel selected a character with two contrasting traits called as stem height, which are the contrasting traits here is tall and dwarf. Whereas in the dihybrid cross, he selected two characters, that is shape of the seed and color of the seed. So which will be the shape of the seed here? Round and yellow. Round and wrinkled. And color of the seed is yellow and green. So how many characters we have here? Two characters, and the traits with the four, that is round and wrinkled for shape of the seed, and color of the seed goes with yellow and green, right? And you have a specific ratio here for monohybrid and dihybrid crosses. What are the ratios here? Here the ratio is phenotypic ratio goes with 3:1, and genotypic ratio goes with 1:2:1, right? Rest of the details we'll discuss when we are discussing the paper. Followed by dihybrid cross is with the ratio phenotypic ratio with 9:3:3:1, right? This part is called as Mendelian inheritance, or it is known as one gene inheritance. So this is followed by a deviation from Mendel's law that is known as incomplete dominance, which was given by Karl Lorenz. So which way the characters taken in the incomplete dominance is given by Karl Lorenz. Color of the flower. Character was color of the flower. And traits are red and white. Okay, so what will be the ratios here? Genotypic and phenotypic ratio is one and the same. So phenotypic ratio goes with 1:2:1, and genotypic ratio also goes with 1:2:1. Can you tell me what is this 1:2:1? 1 stands for red, 2 stands for pink, and 1 stands for white, right? So in the genotypic ratio, we decide the ratio based on writing the genotypes of that individuals, right? So this is a deviation from Mendel's law. Once again, another kind of inheritance you have that is known as codominance. What is the example taken here? Blood grouping will be the example. What is the type of blood grouping we have here is ABO blood grouping. Okay, so what is the special feature in codominance is A group individuals will have the sugar polymers, A type of sugar polymers. B group individuals will be having B type of sugar polymers, and O group individuals will be not having any type of sugar polymers. So what happens here? A group individuals will be called as A individuals because they are having A type of sugar polymers, right? This is one outline what we discuss in this chapter according to codominance. But in the genetics angle, how do we discuss this is ABO blood grouping is having or determined by one single gene, correct? And the gene is determined or designated as I. And the respective alleles for this will be 3 types, that is IA, IB and small I, right? So if it is IA, IB and small I, what are these called as? Alleles of a gene called as I, right? And we can write this in 2 different forms. A in the 2 different forms, B in the 2 different forms, correct? So IA can be written in the homozygous condition, that is IA, and the group name itself is A, right? And the A group individuals can also be written in the form of heterozygous condition as IA and small I, and the group even now will be which group? A group. And IB also will go with the same, writing in homozygous condition, group is B. Same way, writing in heterozygous condition, also group will be B, correct? Whereas I alleles or the individuals who are having O group will be designated as small I. But they don't have 2 versions of writing. How do we write that? We will write it as small I and small I. So this is like how to write the genotype of the group A, group B and group O, correct? Done? Okay, fine. So this is about the codominance. And there is intermediate group here. What is that group called as? AB. This is actually A, B and O group individuals with the respective genotype as homozygous state and heterozygous state for A, homozygous and heterozygous state for B, and homozygous state for O. Altogether, how much genotypes you have? 5 there, right? And other one, a special case here, that is called as AB, where it can be written as IA and IB, correct? So this will be the 6th genotype of the blood grouping, correct? And among this group A, group B, group O and AB, which group individuals will be called as, will be an example for codominance AB. Why? Because in a heterozygous condition, what is happening here? Both the alleles are expressed, and then the condition will be called as, or the inheritance will be called as codominance. So which group will be an example for codominances? AB group will be the example for codominance. So that what are we doing here is, we can't directly jump into just telling about A or B or O, or only speaking about which one. AB will be written as IA and IB. So this will be the example for codominance. We can't directly jump into the concept. We have to go back to what are the other states of A, B and O along with AB, right? So among all these four groups, we are taking AB group as an example for which one? Codominance, because in a heterozygous condition both will be expressed, and hence the group will be called as AB. According to sugar polymer concept, AB group individuals will be having sugar polymer A as well as B, right? Hence the group will be called as AB, right? A will be having A, B will be having B type, O doesn't have any sugar polymer, AB will be having both the types, hence it is called as AB type of sugar polymers, and AB will be the example for which one? Codominance, correct? So that is the fourth type of inheritance, right? So this is regarding the inheritance. I just gave an outline. Followed by this, you have small details about chromosomal theory of inheritance. It is a small discussion what I'll do. This is followed by linkage and recombination. Okay, so what is chromosomal theory of inheritance? Sutton and Boveri, who were the two scientists, Walter Sutton and Theodore Boveri, were the two scientists who proposed the chromosomal theory of inheritance. But when we state that, what do we state? That Sutton united the knowledge of Mendelian principles and stated the law of chromosomal theory of inheritance. And you have certain milestones and all. Hope you know all those details. And followed by this, you have a short discussion of linkage and recombination. So linkage means what is that? Two genes which are closely associated in the chromosome, that will be called as linkage concept. Recombination means association or generation of non-parental gene combination. These two will be the definition for linkage and recombination. So here what is the outline we should focus is, we will be having a chromosomes here. What are these chromosomes called as? Homologous chromosome. And we have a concept saying that if the genes are tightly linked, it means very closely linked like this, what will be the proportion of recombination? Less. In the sense, when the genes are very tight like this, the gene A and gene B, if I designate like this, those are very tightly linked or very closely placed. When these are very closely linked or tightly, closely placed, what will happen here? Recombination frequency will be less. So low recombination will be observed. Correct? Same way, if the genes are far away from each other, say for example A as well as B, right? What do we say here? The distance between the genes is quite far. So what is the rate of recombination? Recombination rate is high. High recombination can be observed. So under linkage concept, you have a concept of more the linkage or more tightly the genes are linked. What is the proportion of recombination? It will be less. When the genes are far, what is the proportion of recombination will be high, right? So it all depends on one factor. What is that factor? Distance between the genes, where the genes are present on the same chromosome. That is very important. Distance between the genes located on the same chromosome. That point you have to concentrate more. Okay, so this is one outline, and T.H. Morgan is the one who's discussing about linkage and recombination, taking Drosophila melanogaster as an example, right? Okay, so that's about a summary of linkage and recombination. And you have a concept of pleiotropy as well as polygenic inheritance, another two type of inheritance. So in pleiotropism, what is observed? Single gene exhibiting multiple phenotypic expression. Same way, polygenic inheritance, many genes controlling one specific character, right? For pleiotropism, which is an example, phenylketonuria as an example. For polygenic inheritance, skin color is an example what we have in our syllabus, right? So those two are the additional type of inheritance, right? So followed by that you have a set of disorders. So which are the set of disorders? Disorders are of two types, which will be called as Mendelian disorders and chromosomal disorders. So how many types of Mendelian disorders we are going to study? There are, first one we are discussing regarding hemophilia. Second disorder will be color blindness. Third one, sickle cell anemia. Fourth one, phenylketonuria, and then last one is thalassemia. These are the four Mendelian disorders, which can also be called as gene disorders, another name. In addition to this, you have another extra disorder, what is called as the cystic fibrosis. But the cystic fibrosis will not be discussed in detail. Instead, hemophilia, color blindness, sickle cell anemia, phenylketonuria and thalassemia will be discussed in detail in our syllabus. And whereas these two will be considered as sex-linked recessive trait, and last three will be autosome-linked recessive trait. Or you can say sex-linked recessive type of inheritance or autosome-linked recessive type of inheritance. So mainly you have to remember these two disorders will come under sex-linked type recessive inheritance, and sickle cell anemia, phenylketonuria and thalassemia will be included under autosome-linked recessive trait, right? And there are three chromosomal disorders which will be known as Down's syndrome, followed by Klinefelter's syndrome, and then Turner's syndrome. So what happens in this case? We have a discussion of aneuploidy state, right? So what is aneuploidy? Aneuploidy is a condition in which what will happen? Failure of segregation of chromatids during cell division will be resulting in increase or decrease in the set of chromosomes, gain or loss. So the conditions in general will be considered as what is the set of chromosomes human beings will be having is 2. So 2n. So we will be going with 2n plus 1 or 2n minus 1. In general, 2n plus 1 it goes, which if it is 2n plus 1, it will be considered as trisomy, right? For 2n diploid set, 1 will be added. Hence it is termed as trisomy. From the same 2n, 1 if it is minus, it will go with monosomy. Then 2n plus 2, when we go with that, it goes with tetrasomy. 2n minus 2, nullisomy, right? These are the various conditions what we write in which case aneuploidy, right? And that will be discussed in the Down syndrome, Klinefelter syndrome and Turner's syndrome. How much the number of chromosomes are increasing, whether it is in autosomes or allosomes, that is what we have to conclude. In Down syndrome, it goes with trisomy 21. What does it mean? One extra chromosome will be added to the 21st chromosome. Hence the condition will be called as trisomy 21. In Klinefelter syndrome, karyotype will be 47, XXY. Where it is increased now? In the sex chromosome or in the allosomes. So normally this will be seen in the males. Down syndrome can be observed in males as well as females. Hence, if a male is having XY, how many extra copy comes now? 1X will be added. Hence, it goes with XXY condition, right? And total number of chromosome in the human beings will be how much? 46, right? Instead of 46, when it goes with plus 1, it goes with 47, and you have to show where exactly it is, whether it is in autosomes or allosomes. It is seen in the allosomes, hence it is 47, XXY, correct? Whereas in Turner syndrome, -1, right? Where it is minus? Sex chromosome or autosome? Sex chromosome. So from 46, if we minus 1, 45 we need to write, comma, sex chromosome is lost. That is one thing. And another very important factor is it is observed in the females. So females will be having X and X. The one who suffers from Turner syndrome will not be having one of this X. So it can be designated as 45, XO. Right? That is how to designate for Turner's syndrome. So what is outlined here? Down syndrome can be observed both in male and female, but very important factor here is it is seen in autosomes. But in the autosomes, which is a chromosome number 21. That is why we call that as trisomy 21. Whereas these two are allosomal conditions, but this is allosomal trisomy, Klinefelter syndrome, whereas Turner syndrome goes with allosomal monosomy. Correct? So that is about the chromosomal disorder. Whereas when we go for Mendelian disorders, we have many things to be discussed here. Right? I'll just tell the key points what is happening here. In hemophilia, one of the protein which is involving in the cascade of the proteins in the clotting factor, that will be affected. So when that is affected, what happens? It results in the disorder called as hemophilia, and actually what the patient will be suffering from is non-stop bleeding, right? That is only the symptoms. Whereas in color blindness, red-green color blindness is a name. The defect is observed in the red-green cone of the eyes. So that is how color blindness is caused. And sickle cell anemia is caused due to substitution of glutamic acid bivaline, that is in the beta globin chain of the hemoglobin. Phenylketonuria is a disorder in which a gene which is producing phenylalanine hydroxylase is affected, and hence it results in the error in which one? Metabolism. So when there is error in the metabolism, what will happen? There are a lot of metabolic pathways has to be discussed here. Phenylalanine cannot be converted into tyrosine, which will be done by the enzyme phenylalanine hydroxylase, right? Now what is the problem here? Phenylalanine hydroxylase producing enzyme will be affected. Mutation is observed there. Hence, this is not secreted in sufficient quantity. So that what happens? The role of phenylalanine hydroxylase will be affected. Its role is to convert phenylalanine into tyrosine, right? So when this is absent, what will happen? It won't convert phenylalanine into tyrosine. So then what will happen? It will accumulate in the form of phenylpyruvic acid, and it will be excreted accumulates in the brain, and which will result in the mental retardation and poorly absorbed by the kidney, and hence it will be excreted in the urine in the form of phenylpyruvic acid. And thalassemia is based on two types, alpha as well as the beta thalassemia. So alpha thalassemia is affected on which chromosome? Chromosome number 16. Two genes are affected, HBA1 and HBA2. Beta thalassemia, beta globin chain is affected, and one gene is affected, that is HBB, observed in the chromosome 11, right? So alpha thalassemia, which chain is affected? Alpha globin chain is affected, and the genes affected is HBA1 and HBA2. Number of chromosome, where is that genes located is chromosome 16. Whereas in beta thalassemia, beta globin chain is affected, that is one thing. Second very important fact is gene is HBB and chromosome number is chromosome 11, right? So that is what you have to notice. So this is about the disorders, right? So now let's move on to the which part? Discussion part of the questions. A small summary I give. So if it comes in between the questions, we'll discuss that now. Any concepts which is needed, we'll be discussing now, right? So the first question goes with, a trait is dash. We have four options here, that is dominant character and phenotypic property, inherited character, and unit use for alleles. So can you tell me which are the options you can eliminate now? Dominant character, the last one, that is unit use for alleles. Those two let us eliminate, and then which one we will select now? Phenotypic property and inherited character, right? But phenotypic property, what does it mean? External observable character. So what is a trait and what is a character? What is the difference between trait and character? Character is single, trait will be contrasting, right? So as per the given option here, where we have to select here now, inherited character will be the answer, correct? Okay, next one. Match the following columns and select the correct option. Column A has flower color, pod color, seed color, right? Column B has, that is 2, violet and white, green and yellow, yellow and green. So which are the flower colors here? Violet and white. This violet and white is a flower color, option A, with the first option, which is that A. That is 1. Correct? Pod color is green and yellow. That is with the second option. Whereas seed color is yellow and green. That is with the third option. So which is the right one here? A. So A1 will be the right choice. Correct? Next one. According to Mendelism, which one of the given character is showing the dominance? Right? Once again. A option tells you terminal position of the flower. Right? B option tells you green seed. The option C tells us wrinkled seeds. Option 4 tells us green pod color. Right? Now the question is on, according to Mendelism, which one of the given character is dominant? Dominant side, right? So which is dominant here? This is position of the flower. How many positions we have? 2 positions. Which are those? That is axial and terminal, correct? This is position of the flower. Second option, that is about the first option. Second option goes with, one second, green seed, which means that, what does it mean? Green seed is the option given, which means what is the color here? The color of the seed is a character, correct? Color of the seed is the character. In this, what is given here? Green. So which are the 2 contrasting traits for the color of the seed? Yellow and green. So now which is dominant? Yellow is dominant, green is recessive. So what happens for the green seed? It is recessive, correct? Second option is recessive. So what happens? You have to avoid it. In the first option, terminal is given. Axial is dominant, terminal is recessive. So terminal as a first option we need to avoid. Third option is wrinkled seeds, which means that shape of the seeds. So shape of the seeds are round and wrinkled. In this, round is dominance, wrinkled is recessive. So what is in the option now? Option has wrinkled seeds. So wrinkled is recessive, so we have to eliminate that. Correct? Option D tells us the last one, that is green pod color, which means that character is pod color. Done? If the character is pod color, what are the 2 colors in the pod? Green and yellow. So here green is dominance, right? So green will be the dominant. So which will be the correct option? Option D, right? So you have to analyze the options in this way, and then we have to select which is dominant and which is recessive. But we should know thoroughly how many characters Mendel has been discussing in his discussion is 7. How many contrasting traits? 14, right? So that is what we have to keep in the mind. So we may go confused with the which is dominant and which is recessive features out of the 7 characters, right? Especially with the color of the seed, which is followed by color of the pod. These 2 are very closest color related things. So you have to remember which is dominant and which is recessive. Done? Okay, next one. What is the genotypic and phenotypic ratio of monohybrid test cross? Correct? How to go with monohybrid test cross? Just define what is monohybrid test cross. Monohybrid test cross means F1 across, which is crossed between F1 hybrid with the recessive parent. crossed with recessive parent. So question is towards crossed monohybrid or dihybrid. That is the main area what we have to concentrate, because test to cross will be for both monohybrid as well as dihybrid. So what happens here? F1 hybrid goes with capital T, small t. Recessive parent will be small t, right? So when we cross that, what will be the ratio? What are you getting? So how will we cross this? How to cross this? Capital T. How to write the gametes here? Circle, right? So how to write the gametes? Capital T and small t. These are the gametes. And how to write the gametes here? Small t and small t. When we go with the Punnett and we obtain this in the ratio, if you put the Punnett square here, we will write capital T, small t as one gamete, small t as the another parental gamete. Correct? So you will get the individuals as capital T, small t, small t, small t, capital T, small t, small t, small t. So how many out of 4, how many are capital T, small t, in the sense tall individuals, and how many are recessive types is 2, which means you're getting that in the ratio 2:2, which can be reduced into 1:1, right? So what will be the test cross ratio here? Test cross ratio will be this option A will be the correct option, that is 1:1, correct? Okay, now let's go to the question number 5. Appearance of a hidden character in some progeny of F2 population indicates. What is the meaning of the question here? Appearance of hidden character. Characters are not expressed, which is hidden, in some progeny of F2 population indicates. Let us go with the options first. Option is A tells you law of purity of the gametes. Second option, law of independent assortment. Third option goes with law of dominance, and the fourth option goes with complementary genes, right? Now which options we need to eliminate first? Law of, why? What is the reason? Why do you eliminate law of dominance? Because here in the question you have appearance of hidden character in some progenies of F2 population indicates, right? You are getting into which population? F2. Suppose if you consider monohybrid cross, that is law of dominance, with tall and the dwarf. How are the F2 individuals? Capital T, capital T, capital T, small t, and small t, small t, right? So what does that mean? It goes like this. So in the F2 generation, we will get, I'm directly jumping into F2, capital T, that is homozygous tall, and heterozygous tall, and homozygous dwarf. This is the individuals. Question is towards which one? F2 population indicates. This is F2 population, right? 4 individuals we got. 1 is in pure homozygous tall, 2 are heterozygous tall, and 1 is homozygous dwarf. So what is the question asking you? Which is a hidden character appearing in some progenies in the F2 population indicates. Which law? It is law of purity of gametes, law of independent assortment, and complementary genes. Avoid complementary genes, which is not at all touched in a syllabus, right? So we need to go, either it is with the law of purity of gametes, which can also be called as law of segregation, right? And then law of independent assortment, right? Law of dominance is the first law. Law of segregation is a second law of Mendel. Law of independent assortment will be the third law, right? So in this, which one will be, what is the question? Appearance of hidden character in some progeny of F2 population indicates which one? Law of purity of gametes, correct? Fine. So, next one. Okay, sixth one. When a tall plant with round seeds, what is the genotype? Capital T, small t, and capital R, capital T, capital R, actually it is like that, crossed with the dwarf plant with the wrinkled seeds. First character is tall plant with which one? Round seeds. Another one is dwarf plant with the wrinkled seeds, right? Parents are in that condition, correct? And in F1 generation consists of tall plants with the rounded seeds. How many types of gametes F1 plants would produce, right? So let us work that. How to work it? So how are the parents now? Capital T, which is tall and round. One parent is tall and round, work it out. And another parent is dwarf and wrinkled, correct? Two parents are given here. The F1 generation consists of tall plants with the round seeds, which is exactly what type of cross is this? Monohybrid or dihybrid. In Mendel's dihybrid, we had round yellow, wrinkled green. Here what they did is just shifted the character from round yellow to tall and round, which is followed by dwarf and wrinkled, right? Stem height and shape of the seed, right? So which is stem height? Let me write the character. Stem height will be tall and dwarf. So how to express tall and dwarf? Capital T and small t. Two are dominant alleles and two are recessive alleles. Those two are available here, right? Another character is round and wrinkled. So it is shape of the seed, which is round as a dominant character as well as wrinkled as recessive character. Round will be written as two dominant alleles. Since wrinkled is recessive, we will be writing that in the recessive form, small r. Now what is the F1 generation? Let us directly move on with the F1 generation. How to write the gametes here? Capital T, capital R and small t, small r. In F1 generation, how will we obtain the products? RRYY, what we used to get in the round yellow wrinkled seed of dihybrid cross. Here it is capital T, small t, capital R, small r. So what is the condition? Tall and round, right? Plants are tall and shape of the seed is round. Tall and round. So let us focus on the question. So what does the question ask you? How many types of gametes F1 plant would produce? How many types of gametes F1 plants will produce? 4. Which are those? Capital T, capital R, this with this, and then capital T, small t, capital R, and small t, small r. Very similar to the gametes what we have worked in the dihybrid cross, right? So just a character is shifted. You should apply for dihybrid cross and then work here. So altogether we get 4 types of gametes. So option is having types, 4 types. Numbers are given here, 1 or 8 or 3 or 4 as such. And types of gametes, if it is asked, you may also get this in the option. So in such cases, you will have to work and write down the which are the types of gametes. Correct? Finish working. Okay, next question is, incomplete dominance differs from codominance as in former. So you have two things to be taught now. One is incomplete dominance. Second concept is codominance. Incomplete dominance, just recall the content. What all concepts we have? Who proposed this? Karl Korensch. Character considered was color of the flower. Traits were, this much you have to recall, these many facts. Red and white, right? And as he crossed in the F1, he will get pink, which is deviating from the Mendel's inheritance. According to Mendel, it will be red, right? But according to Karl Korensch, it will not be red. When you write capital R and small r together, it will be pink in case of incomplete dominance. So that is one outline. Codominance, purely you have to focus on blood grouping, where which is a blood group we have focused just now. I told IAB group, where it is written in the form of IAIB. In which condition? Heterozygous condition, where both the alleles are expressed, right? That condition is called as codominance. This is the meaning of this question. Right now, let us read the option. Option A tells you there is no mixing of effect. Okay. Option B tells us the expressed phenotype is combination of two phenotypes and their alleles. Option C tells us hybrid possesses new phenotype. Option D tells us a quantitative effect is absent. Just tell me what is the option what you can eliminate, which you feel very irrelevant. Option 1 or D? I'll be asking with 2 now. Option 1 is there is no mixing of effect. Option D tells you a quantitative effect is absent. Option D is the first elimination. Then option A will be the second elimination, right? Okay, let us go with the option B and C. Option B tells us the expressed phenotype is combination of two phenotypes and their alleles, right? So how it is given? Expressed phenotype is which one? Capital R, that is red. Capital R, small r, that is pink. Small r, that is white, right? What is the option saying you? The expressed phenotype is combination of two phenotypes and their alleles. That is the second option. Option C says you hybrid possesses the new phenotype, which is more appropriate option. Option C, which is a new phenotype we got here. It is pink, right? So option C will be the answer, right? Because we get a new type of phenotype in a hybrid, because when two parents are crossed in the F1, we will get the hybrids only. The F1 generation will be generally called as a hybrids. Why? Because it is a product of the cross between the two parents. Hence it is F1 hybrid generally. So here it is, since it is incomplete dominance, how it is differing from codominance as in former. This question is mainly for incomplete or codominance. Incomplete dominance, right? So that is why first you have to differentiate between which one? Incomplete and codominance. What is the difference? You have to make it out. And then it is asking or demanding on which term in the question is incomplete dominance. These many facts you have to fix first and then read the options, right? And then eliminate and then select, correct? So which is the right one here? Option C. Next one, match the items given under column 1 with those of the column 2 and select the correct options. Okay, option 1 says that in the column 1, genotype, recessive, hybrid and phenotype. Column 2, an organism produced by a cross between two individuals of differing in certain characters. Option Q, observable characteristic of an organism. Option third one, that is R, a trait that remains hidden in a heterozygote. Option yes, an organism with contrasting alleles of a character. T, genetic constituent of an organism. Okay, let's select now. Genotype stands with genetic constitution of an organism. Now go with A, B, C, D. One matches with the T, goes with the A, B, C option. So what are we supposed to eliminate? Eliminate option D, right? Okay, then we have A, B, C in our hand now. Done? Now let's go with the second one, that is recessive. The trait that remains hidden in a heterozygote. Where is that? Again with the A, B, C. Second one is going with R only. All three will be in your hand even now when you are in the second one. Option 3, that is hybrid. An organism produced by a cross between two individuals differing in certain characters. That is with P. Option A. Now when we reach the point 3, what happens? B and C will be eliminated. Then selected answer is A, but don't rush there. Go with the fourth and read the option clearly. That is, you have an extra option even here. That is why. So phenotype goes with observable characteristic feature of an organism. So 4-1 will go with the Q. So selected option will be option A. Correct? Okay, let's go to the 9th one. Again, match the following. Here also you have 4. Monohybrid cross, test cross, alleles and homozygous tall. Which is monohybrid cross? This. Monohybrid cross. Is it third option? Why it is third option? Monohybrid cross. When we go to the other options, we will go with, because monohybrid cross generally goes with, one second. Normally your cross goes with capital T, small t, right? But do we have that in the option? Capital T, small t, first parents. Do we have this in the option? No. So we get a F1 here as capital T, small t, and when these are self-pollinated. So we have this in the option. We don't have your original parents in the option. So generally when we think in the options what is available, that option has to be selected, right? So in the monohybrid cross, which one we can select now? Option. One second. Option 3, right? Step by step we'll go, don't directly select. Test cross goes with option 5, already discussed now, that is capital T, small t, means F1 hybrid crossed with the recessive parent. So where are we now? Monohybrid cross with third one. We have A, C and D in our hand. Which one to eliminate? B to eliminate. And then test cross goes with option 5. Again, which to eliminate? B and D to eliminate. We have option A and option C, right? Let's go with the third one, that is alleles. Where to go? Alleles are capital T and small t. So that is with 1. Option A will be eliminated now, and the option C will be 1, that is alleles will be first option, that is T and T. And the left out one is homozygous tall. Which is homozygous tall? Capital T, capital T. You have which in the option? Option C. So option C will be the right option. Correct? Okay, next one. Assertion and reason. Here, both the alleles in a codominance are equally important. That is the first option. Do you agree? Yeah. Next option is, in codominance, the number of phenotypes is the same as the number of alleles. Okay, then how will you, why not the answer? Number of, what is that? Phenotypes is same as the number of alleles. How many phenotypes we have? 4. Which are those? A, B, and O. And number of alleles are 3. That is IA, IB, and small I. Right? So what is the sentence saying? In codominance, number of phenotypes is same as the number of alleles. It is wrong. Correct? Where we have that? Option C. A is correct, but R is not correct. Right? Okay, next one. In a cross, if a cross is made, just correct that. If a cross is made between capital A, what is it called as? Dominant alleles. The condition is homozygous dominance condition, right? And small a, homozygous only recessive state. So these are the parental types. When a cross is made between these two individuals, the nature of F1 progeny will be, in what condition? A. These are capital A and small a. Question is, if it is cross between two, right? If there is a cross between two, the nature of F1 progeny. How will be the F1 progeny? Exactly similar to which cross? Monohybrid cross. There the characters were capital T, small t, tall and dwarf. Instead of that, here the alleles has been changed into capital A and small a. Concept is same, right? So directly don't think this is some new alphabets given here and you can't just imagine something new is here. Same concept. What is that? Alphabets are shifted from T to A, right? So what will be the F1 generation? Capital A, small a, right? This is a F1 generation concept, right? So what is options now? Okay, first so much you have to do. Now let's move on to the options. Options are quite different. First option is saying genotypically AA and phenotypically small a, right? Which one is wrong? Option A is wrong. Option B says genotypically capital A, small a. That's right, what you got now. And phenotypically small a. Wrong. Okay. Option C, genotypically doubted. A and A. Phenotypically also A and A. I'm just reading out. Let's go for the eliminations later. Option D, genotypically small a, phenotypically capital A. Okay. Where is genotypically capital A, small a? Select that first. Those two options. Option B and C. So A and D, don't think about that now. So keep it aside. These two will be in your hand. Now genotypically AA, phenotypically small a is an option. What is that? Option B. Correct? Option C says that genotypically capital A, small a, phenotypically capital A, small a. Okay. So which is the right one now? Why? Why? A small correction here in this question. It is genotypically AA correct, but here there should be single alphabet, right? What is that single alphabet? Capital capital A. So where shall we put capital A? Here it is better, I guess, because genotypically AA, right? In which option you will take? B option, genotypically AA, phenotypically capital A you put. Because phenotypically always it gives you the external observable character, right? So that capital A is deciding the feature here. Since the character is not at all mentioned, it is alphabetically mentioned here as either it is capital A or either it is small a, right? Clear? Okay. Next one. Which of the following genotypes does not produce any sugar polymer on the surface of the RBC? Option D, just now it was discussed. So AA will be having A type of sugar polymer, I will be having B type, IB will be having AB type, and both small i's, that is alleles to express, will not be having any sugar polymers, right? So option D. Okay, next one. The first chromosome map was made by. Option C. What is his full name? Alfred Sturtevant. So you have Morgan, Bridge, Bettison and Punnett. So can you tell me what is the contribution of Morgan? Linkage recombination is a concept given by T.H. Morgan. Animal selected was fruit fly, that is Drosophila melanogaster. And Bridges is familiar for giving the sex determination in the genic balance theory in sex determination, where we don't have his concept in our syllabus, right? Genic balance theory of sex determination is a concept what he is actually discussing, right? Whereas Alfred Sturtevant is actually the one who has given the genetic map. Bettison and Punnett. Punnett, you may know them. You may know him. What is his full name? Reginald C. Punnett. What he did? He proposed the Punnett square. What about Bettison? He is very familiar. Just keep his name noted. He was the one who coined the term genetics. And there are other contributions as well. For the time being, just know Bettison is a scientist who coined the term genetics. Even Bridges have other contribution also. Even Punnett has other contributions. So one main, contributions will be highlighted in the option, right? Okay, next one, question number 14. Assertion and reason once again. The number of chromosome in one genome is equal to the number of linkage groups. Number of chromosome in one genome is equal to the number of linkage group. Question number 14. Reason. The homologous chromosomes form a linkage group. What do you feel? Okay, first you have to decide now whether the assertion and reason is true or false. Okay. So number of chromosomes in one genome is equal to number of linkage groups. What does it mean? What does it mean? Number of chromosomes in one genome. One genome means always it is haploid set. Correct? Haploid set of genome. Always, when genome word comes, it is always referring for haploid set, right? So the option says that number of chromosomes in one genome is equal to number of linkage group. In the haploid set, how many chromosomes are there? That is equal to how many should be or is equal to number of linkage groups. Correct? Is that statement true? Linkage groups means what? Genes are very closely linked. That is called as that genes which are linked together. You call that as the groups of linked genes. right? Terminology we use here is linkage groups. You may feel that it is quite different. It is not a different concept. Comes within the linkage concept only, right? So just write down what is linkage groups in short. Genes located on the same chromosome, or collection of genes on the single chromosome. Collection of genes on the single chromosome. Now tell me whether it is true. Number of chromosomes in one genome is equal to the number of linkage groups. Means just linkage group makes us to understand the set of genes or the collection of genes on a single chromosome, right? So chromosome will be equal to what? Number of linked groups, correct? So A will be correct. Option 2 says that two homologous chromosomes form a linkage group. For example, if you take 23 chromosome in the human beings, how many linkage haploid set it is? N is equal to 23. Diploid set will go with 2n equals to how much? 46, right? percentage of gamete produced by that parent will be, how shall we work? A plus B whole square. No. Okay. How shall we move to solve this? First we have to find out the gametes, right? Okay. So how to find out the gametes? So now these are the parents. Capital A, small b, capital B, small. Correct? So how are the parent? That is a parental condition. So you will have to find out the gamete now. So how many gametes we can get? This A with this B, capital A, capital B, capital A with small b, and then small a, capital B, and small a, small b. Now question has the percentage of AB gametes produced by this parent. Where is this AB? 25. This AB is here, right? So this is one way how to solve this. Percentage is how much? 25%, right? Okay. So when we go with the number of gametes formed, what formula we were using? 2 power n. When n goes with number of heterozygous conditions. Formula used to find out what is that? How many gametes are produced. Correct? How many number of gametes. This is one way to do. This is using formula you are doing this. So 2 power n goes with how many heterozygous? 2. This is one heterozygous condition. This is another heterozygous condition. Right? So n goes with, stands for how many heterozygotes? So 2 power 2. How much you are getting? 4. So how many gametes you got now? This is your proving how you are getting. 1, 2, 3, 4. Right? So 4 types of gametes we get. But the question has some other demand. It is not demanding on how many types. It is asking what is the percentage of this type of gamete in the given gametes. I mean in the gametes what we get. Right? Okay. Now the 18th question is. In polygenes, the dominant alleles have polygenes. Now recall the content. Polygenes means polygenic inheritance, right? Where skin color will be the example, right? So how many genes control the skin color? 3 genes, which are those? A, B, and C are the genes that control the skin color. Now what is the option saying you? No effect, negative effect, cumulative effect, no dominant gene persists in the nature, which will be our elimination. So let us follow the eliminations method first. Which shall we eliminate? Okay, option A. Then the last one, that is no dominant gene persists in nature. Why? Because your skin color, which is what is that? Controlled by the polygenes, is controlled by dominant genes itself. That is A, B, and C. So you need to eliminate no effect and no dominant gene persists in nature. Another one is negative effect. Of course, even that is not the relevant one. The concept gives you an idea about what type of effect it is. Cumulative effect, right? So this is the answer. Or another name given for cumulative effect. Additive effect. Additive means what? The skin color, what we have is the additive effect of gene A plus gene B plus gene C. In the sense, gene A cannot give you, alone cannot give the skin color, nor B nor C. So all 3 genes in a dominant condition, when it is expressed, what will be the color of the skin? A, B, C, C. What will be the color of the skin? Dark. Small a, small b, small c. In the recessive state, the color will be light. Okay, this is what characters. Just eliminate which is the one which you don't want from them. Which is that? Mutation. Okay. Then leakage. Okay. Then dominant character. So is recombinations are due to independent assortment of genes. Right? Correct? Next one. Distance between the genes and the percentage of recombination shows. As I discussed shortly now, more closer is the genes on the chromosome, what will happen? The rate of recombination is less. Distant the genes, the rate of recombination will be higher. So now read the options. They have direct relationship or inverse relationship or parallel or no relationship. Inverse. Direct. It depends directly on the measure of distance between the genes mapped on the same chromosome given by Alfred Studebaker. Correct? So it will be distance between the genes and the percentage of recombination. Because of that only we say how is the percentage. Based on the distance between the genes on the chromosome. So it will be a direct relationship between the distance of the genes on the chromosomes to that of the percentage of the recombination. Correct? Okay. Next one. Which pair of features represents the polygenic inheritance? Wait, don't jump. Human eye color and sickle cell anemia is one option. Hair pigment of mouse and tongue rolling in humans, because two options are there. Two features are here. Option C tells you ABO blood groups in humans and flower coloring mirabilis jalapa. This is for codominance, that is for incomplete dominance. Eliminate C. And option B, human height and skin color. Now select the answer. First, you without reading the option, the selected answer is human eye color, which has even sickle cell anemia over there. Right? One may be correct, the other one may be wrong. So two features when we have in a single option, one part may be correct, half of it may be wrong. So in case of all four options, which two features are matching for the polygenic inheritance? Human skin color is the one what we discussed in our chapter. As we have in the first option, you have human eye color, right? As well as sickle cell anemia there. Sickle cell anemia won't be the example for polygenic inheritance at all, right? So eliminate even that, even option B and option C, which is the one what we are discussing. Skin color in our chapter, along with that, stem height, human height also can be the example for polygenic inheritance. Correct? Okay, now, see how to work it out. In garden pea, yellow color of the cotyledons is dominant over green and round shape of the seed. Right? Over green and round shape of the seed is dominant over wrinkled. Correct? When a plant with yellow and round seed is crossed with a plant having yellow and wrinkled, the progeny showed segregation for all the four characters. The probability of obtaining green round seeds in the progeny of the cross is. Now, how shall we proceed to work this? Do we need to work everything, or can we just simplify the discussion? Okay. How shall we simplify this? What shall I start? So let us go finally jump into which one? Your ratio. What is the ratio we are having? 9:3:3:1 as a phenotypic ratio. So we will get 9:3:3:1. In this 9:3:3:1, what stands for 9? Round and yellow, round and green, wrinkled and yellow, wrinkled and green. Shortly I am writing, I am not writing verbally. So now this is what we get. So So what is the option asking, sorry, question asking you, the probability of obtaining green round seeds in the progeny of the cross. Where is your green and round? Round yellow, round green. This is the part of the question. Probability of green round seeds. How did I write? Round. Green and round, round and green is one and the same, right? So, what is the probability of out of 16? In the Punnett square, how many individuals will get? 16. Out of 16, how many are round green? How many are round yellow? This way. So, round green is 3. Round yellow is 9. Wrinkled yellow is 3. Wrinkled green is 1. So, maybe you may get some other features even. Now, the feature asked here is this category. Green and round. So, out of 16, you should get 3. Where is your option? Option B. This is out of 16, 3 are round and green. Right? Now, the next one. You have to arrange this in the order. Some genomic representation of skin color are given below. Right? How are the expressions? First option. First allele is in dominant. Second one is in recessive. Third is in dominant. Third option. First is in dominant. Second and third is in recessive condition. Whereas third option, all three are dominant alleles. Fourth option, all three are recessive alleles. Now you need to arrange with respect to showing the darkness of the skin in a decreasing order. Who is more dark? Which man? Third person, right? Totally all three are dominant alleles, they are more dark. Where is your option? Option B and option C. Eliminate option A and B, right? So, let us go with the second one. Now, 2 alleles should be dominant. This is already done, right? It's already selected. Next, where are 2 alleles dominant? This one. So, third and 1. C. Let's check with the second one. Where is your second one? 1 is dominant, 2 are recessive. So, that person will get the third place. And the last person, where is the last person? He is totally light. Light in the sense, fair skin color, right? So, when we arrange from darkness to light, third, this one will get the first place, this will go in the second one, and in the this one will be the third, and the fourth individual will be in the last place with respect to darkness of the skin. Correct? Next one, 24th one. The number of phenotype recombinant offsprings formed during the F2 generation of the dihybrid cross. Now, let's get back into this ratio once again. They are asking you the number of phenotype recombinant offsprings formed during the F2 generation of the dihybrid cross, right? Recombinant, which are the parental types in the dihybrid cross? First, you have to think about I'll write the genotype. Round, yellow, and then wrinkled. These are the parental types. So, round yellow, wrinkled green are the parental types. So, where are your round yellow, wrinkled green? This is round yellow. This is wrinkled green. Same ratio you can write and working for this to simplify the discussion, right? So, these are parental types, correct? Now, when we get the F2 individuals, which are the new varieties other than the parental types are round green and wrinkled yellow. So, how much you are getting? Which should be 3 plus 3, that is equal to 6. So, where is your 6 by 16? In the sense, these are called as, I can say this as recombinants. It's another way to express that. Recombinants or recombinant offsprings, right? So, same way, the question may be asked in the form for which are the many? 9 plus 1 are the parallel. So 3 plus 3 will be, that is 6 are recombinants. Whereas 9 plus 1 goes with 10, those are parallel. In case of the question demands on which are the parental types, you should be able to work it. Correct? Done. Now, 25th one. Select the correct statement. Tightly linked genes on the same chromosome show very few recombinations. Option B. Correct? Option B. Tightly linked genes on the same chromosome show higher recombination. No. Genes apart on the same chromosome show very few recombination. Genes apart means genes are quite far. On the same chromosome show very few recombination. No. Why? Because they show high recombination. Option D. Genes loosely linked on the same chromosome show similar recombination as tightly linked genes. No. Which is the right one? Option A. Option A. Hope you understood the sentence, right? Then we'll go on to the 26th one. XXXO type of sex determination is observed in females producing only one type of X. Option B. Females have only one X chromosome. Option C. Males have two X chromosomes. Option D. Males are homogametic. Which is the right one? XXXO type of sex determination is observed in which one? Which organism? That is in insects. Which is the insect we have? Grasshopper, right? So grasshopper as an example we discussed in this chapter as XXXO type of sex determination. So fix so much for the question, right? Now read the options. Females producing one type of X. So in XXXO type, which is a female, which is a male? X is female, XO is male, right? Option 1 says females produce only one type of X, right? Option 2 says females have only one X chromosome. Is it true? No. It has how many X chromosome? 2 X. Males have 2 X chromosome. No. Why? It has one and one nil. Whereas males are homogametic. This is male. How are you writing males? XO. If you write like that, what condition it is? Heterogametic. So what will be the answer? That cannot be the answer. So females produce how many types of X? One type of X will be the right answer. Right? Okay, next one. 21st. 27th. Observe the sex determination in the following column and select the correct options. Male heterogameity, female heterogameity and male homogameity. What shall we select for male heterogameity? Human X. One is this one. The other one is there is 1 and 3. Option D has 1 and 3. So that you select. Let's check out with the option B. That is female heterogameity. NZW. Male homogameity. Birth Z. So which is the right option? D. Option D. Correct? Read out? No. The next 28th one. Find out A, B and C in the diagram given below. Right? quite easy. Directly from the sentence. A is X. That is, see the fusion. One of the female gamete fusing with the male fusing with the female, giving rise to X size. So A stands for female. Correct? One male gamete fusing with the one female gamete, giving rise to XY. Male. Correct? C gamete. Right? Option C is the right one. Correct? Next one. The primary biological importance of sex in the organisms is that. Why the sex in the organisms is essential? Biological importance. Promotes, mainly they have been telling here and there, sexual reproduction is the one which permits the variation. So that is the main reason for the variation is sexual reproduction. So the biological importance of sex in the organism promotes the genetic variability in the offspring. Right? It is not meant just for limiting that. Option 6 says that is essential for organism reproduction. Sex is not meant only for reproduction. Due to that, we have to get some significance. That significance is one importance, what we are focusing. On that option, we have to, rely on and select that. Right? So, option D will be the correct one. The last one, the 30th one, we'll do that and we'll stop. The genetic makeup of sperm determines the sex of the child in the humans. In humans, so A is correct, right? Reason. In humans, males are heterogametes. So, what to eliminate now? Option A and B, which one you select now? Option A. Option A. Why? Males are heterogametic, that is X and Y, and that is how we can distinguish between the human males as well as human females, and that determines the sex of the child. Right? So shall we stop now? So you have 10 more questions on the class test only. Keep working. And few questions. Once again, this questions we have worked in the class regarding how to express in the genotype and how we get the proportion of the children being colorblind or being hemophilic. Hemophilic condition one question you have, plus colorblind one question you have. Right? Rest of the questions you keep solving. Right? Thank you. Have a good day.